Hello and good morning and welcome to first day of NahamCon. My name is Ben Sadegapur, but most of you guys know me online as NahamSec, and we're excited to show you guys another successful year of NahamCon. A big thank you to our sponsors for making this year's event happen. It wouldn't be possible without them. So big shout outs to them. You can see them all down here. They're the reason why we can make this conference and keep it free for everybody attending. This year we're doing the HomCon a little bit different. Usually you're used to seeing the HomCon on a Saturday with one day and about 9 to 10 hours of content, but doing 9, 10 hours of content is usually very, very exhausting. And I know a lot of people get tired halfway through. So this year we're doing things a little bit different. What we're doing this year is we're introducing 2 days. The first day is going to be the villages. So Red Team Village, IoT Village are also live at the same time on Twitch right now, or they're going to be going live in just a few seconds. And they are also doing their own type of workshops and talks. So if you're interested in something else, make sure you go to the website. It's on nahamcon.com. The spelling is right here above my head. You just go to nahamcon.com and you can see all of the other workshops and speakers as well. For this village, and specifically, it's in partnership with Bug Bounty Village, which is another village that we put together with NahamCon. And what we're doing this year is we're going to host a bunch of free workshops. So starting off today, the first one is the CTF workshop. We figured with how big our CTF is every year at NahamCon, why not partner with one of our sponsors, Sneak, and bring to you a workshop around how to do CTFs and get started. So if you haven't already, you can also get started with our CTF at NahamCon, or next year you can come back and participate and maybe win some of our cool prizes. So the CTF is in full effect right now. If you want to play, it's on ctf.nahamcon.com. There's $5,000 up for grabs for the top 3 teams. And then after the Sneak workshop, we're going to do a smart contract workshop with our other partner, Halborn. And then we're going to move on to Burp Suite. And the last thing is going to be Tiberius coming and doing some Prevesk stuff. Unfortunately, Jason Haddix will not make it to the conference as we promised. He had some personal issues that came up. So unfortunately, he will not be here for his portion. But we still have a jam-packed day of good content for you guys. All right, enough about that. I'm going to put myself into backstage and welcome our first workshop in partnership with Sneak. Sonia and Mika are going to join us. So I'm going to quickly go backstage and bring them on. And then we are going to start off with our first workshop.
All right. Hello, everybody. Hello, NahamCon. Welcome.
Hey, welcome, everyone.
I feel like I should raise my seat up a little so our heads match. It's okay. All right. So if you would please put my screen in to our lovely producer, Sweet, we will kick things off here. So this is the CTF 101 workshop. If you're a very experienced CTFer, this may be some review for you, but you might learn something new, so stick around. Let's start with some introductions. So, and clearing of throats. My name is Micah. I am a director here at Sneak. I run our acceleration team, and we do workshops just like this. This is one of among a bunch of workshops that we do. I'm a longtime Java developer. Don't hold that against me out there. I appreciate it. Let me go ahead and have Sonia introduce herself.
Hey, everyone. I'm Sonia. I'm a senior security advocate at Sneak. I'm passionate about DevSecOps, cloud security, and open source. And yeah, we're going to have some fun today. So let's do this.
Sweet. All right, let's kick it off. First, I got to clear my throat. One sec. All right. With that out of the way, we have a couple of prerequisites. Now, we're going to be very focused on 2 challenges. They're kind of entry-level challenges. One is harder than the other. I'm going to do the easy one, and we left the heavy lifting to the capable and great Sonia. So you need a text editor, Node.js, Python, and curl, ideally. You can register on our platform here at 101.ctf-sneak.io. You can register for Sneak. It's not required that you have a Sneak account, but it will give you a leg up on one of the challenges that we're going to do. And then as a bonus, if you want to install the Sneak CLI or Sneak IDE integration, that'll help you out also as you go. But again, not a requirement. We got a couple of links here. We have a Discord if you want to chat amongst yourselves. We do encourage helping one another, and we'll see in just a second when we have kind of a ground rules slide. Helping each other is very encouraged. Just, straight up giving away answers is not encouraged on any CTF. And so you can register again at 101.ctf-sneak.io. Here's our agenda. We're going to talk about why bother with capture the flags. What is this thing, capture the flag, and why is it useful to you? As the thing that's cool about capture the flags is it cuts across a lot of different professions: security professionals, developers, operations people. We all like participating in capture the flags. We'll talk about what is this thing, a flag anyway? What is it? And then we'll dig into our 2 challenges. And for each of the challenges, we're going to present the challenge. We're going to give you, this is almost like an SAT prep course if you're in the US. It's like how to go about sleuthing CTFs. So for each of the challenges, we'll present the challenge. We'll look at the clues. We'll give you some time to solve the challenge. We'll give you a hint, give you a little more time, and then we'll present the solution. So there are going to be spoilers. We will present the solutions for each of these. So why bother with CTFs at all? Well, the cool thing is that they're cross-functional. You don't really need to be an expert in any one discipline to participate and do well in a CTF. It cuts across languages, databases, different types of protocols. It's really more about developing these sleuthing skills and poking around the edges, and frankly, how good a Googler you are to kind of follow the breadcrumbs. And that's a really great way to keep the sauce sharp. There's a lot of learning involved, which is great. It's also very social. Some CTFs require you to be on a team, so it's literally a team sport. But even if you're not required to be on a team, most CTFs will have some channel for communication, and people will ask for hints and drop clues. And there's a certain etiquette. If somebody asks for a hint, you can DM them a hint. If somebody's talking in a public channel, it's okay to kind of drop little cryptic messages, but you don't want to give anything away. You don't want to, it's kind of like going to see a movie and then spoiling it for friends. People get pretty rowdy about that sort of thing. So this thing we call a flag, it can come in many different forms. The ones that we're going to be looking at, it's always a digital bit of information that you put into an input form somewhere, usually in the CTF sort of platform. And then if it's correct, you'll get points for the challenge that you've just solved. For the ones that we're going to be working with, they have this format where it's sneak and then a set of curly braces and then a long hex number inside. Now, if you're like me, you definitely would check and see if this was a real flag or not. So don't take my word for it, but this is not a real flag. This is just an example, but you'll know that you've solved a challenge when you see something like this, sneak with the curly braces. All right, some do's and don'ts. Feel free to share your progress. Feel free to tell people, I got this one, or I'm almost there. You can definitely ask questions in a public channel, and you can talk to each other for clues, but make sure that you're DMing each other if you're giving like very specific hints, and never, whether by DM or in a public channel, do you want to give, a full solution. So don't tell spoilers. And this is kind of important. And this is not just for our little CTF 101 here. This is CTFs in general. There's almost never a case that I can think of where the solution, a flag, is going to be revealed by bringing the site down or, flooding it and giving a denial of service attack. That's kind of outside of the spirit of what a CTF is. And oftentimes the challenge servers are very lean, like kind of single instance images running in the cloud. So you really don't want to hack the back end. That's not going to get you the flag anyway, and it's just going to kind of ruin it for everybody else. All right, so let's jump into our first challenge. And let's see, I'm a little curious. if everything I just said was covered up by the ad. I sure hope not. But anyway, I'm gonna press on here. Our first challenge is called Invisible Link, and oftentimes the name of the challenge itself gives you a hint as to what may be going on. Sometimes it's a misdirect. There's a lot of misdirects in CTFs. But sometimes, so just kind of file it away. The name of this is Invisible Link. Maybe that'll be useful. Maybe it won't. And where we're going to start is at the server here. Oh my goodness, I'm already giving spoilers. So if you go to 101.ctf-sneak, you'll see there are two challenges, and we're going to start with Invisible Link. Now, right out of the gate, we get a couple of clues, and just looking at this, especially if you haven't done a CTF before, you may not realize, well, what do you mean clues? But you want to start thinking like this is going to leak some information to me. So first of all, points, 50 points. That's relatively low. And so we would expect that this would be an easier type of problem compared to the other ones. Now, it might not, that doesn't necessarily mean it's going to be easier for you or for me. It depends on what your existing knowledge is. It depends on, things you might already know, how good you are at sleuthing. But we can say, relatively speaking, this one should be easier compared to other ones. We also know that it's based on JavaScript. Sometimes you get this information, sometimes you don't. So you may have a leg up on this if you're already well-versed in JavaScript. We also know that there's a web application involved and that we're going to expose some hidden vulnerabilities in the web application. Well, that's some good reconnaissance there. That's some good information. We have a server, so we're going to click on this link in just a second. We have a hint. One thing you want to pay attention to is certain CTFs will deduct points, excuse me, if you reveal a hint. But it'll always say if it does. So it'll say something like view hint, minus 10 points. In this case, there's no point deduction, so you can view the hint. And then finally, we have these two files, index.js and package.json. Now, you don't always get files in a challenge, and this is one of the reasons that this is a lower point challenge, because when you have the files that make up the server that we're going to be looking at, well, that gives you a huge bunch of hints if you can look at the source code. All right, so let's take a look at, let's just review the hints that we have. So we know it's JavaScript, we know that we have these files, and we know it's about hacking a web application. Now, in case you're not familiar with HTTP, because that's the protocol behind the web, it has these different methods, and we're not going to get deep into them. And by the way, as an aside, this is one of the things about CTFs. It's rare that you're going to get deep with anything. That's not the point. The point is not to be, an expert at the end of HTTP. The point is to gain just enough knowledge to help you find that flag. So HTTP has these different methods. We have get, post, and delete. You can kind of think of it like a bulletin board. When we're doing a get, we're reading content off the board. When we're doing a post, we're placing content on the board, and a delete is removing content from the board. So with all of those hints under our belt, let's take a look at the actual server here, which I have up on this other screen. And so when we go here, it's telling us post and echo with content type application JSON. So post to this endpoint. This is an endpoint with content type application JSON and body. This is a JSON body, and then we'll get a response. That's what we expect to get. So the first thing I'm going to do, and what this is kind of telling me is I need an HTTP client of some kind. I need to be able to make a post. There's a bunch of popular ones. Most machines these days, most OSs come with curl built in. That's the one I'm going to use. But there's also HTTP, there's Postman, any HTTP client of that you're comfortable with or can learn about quickly. And then what we're going to do is we're going to do a curl command as we've been instructed. So let's first do exactly what we've been instructed to do. This is our URL here, invisible-inc.c.ctf-sneak.io. And it's telling us we want to make a post to this echo endpoint with this particular header called content type application JSON. Now, this is something I happen to know about. And so I know how to use curl. I know how to send headers. So here's the format that it takes. And I'll drop this into chat in case you're not that familiar with curl. But we're going to do a post. We're going to do a post to the echo endpoint. We're going to give it this header, content type application JSON, and we're going to give it this data. And this is the JSON that we're going to send to it. And then we expect to get back a response that looks very similar to what we saw on this landing page. All right, let me copy this and drop this into chat. I think I can chat. Let's see. Huzzah. Okay, so there we go. Now, of course, the goal is to find the flag, and we kind of get a new hint just in executing this curl command, because if you notice, the response includes flag disabled. Well, that's kind of interesting. That's a big clue, and maybe this is going to be super simple. Maybe I can just say something like flag enabled. Maybe I can just do that and it'll give me a flag back. Let's see. Well, no, it still says flag disabled. But, you know, if you're a lazy developer like me, you want to try the low-hanging fruit first. So with all that, I'm going to pause here for a moment. So we know how to interact with this endpoint. I'm going to give you 2 minutes to play around with this, see how far you get. Feel free to drop messages in chat. Feel free to talk amongst yourselves. I'm putting 2 minutes on the clock, and then we're going to go into our first hint. And unfortunately, I haven't queued up any background music, so I'm just going to leave that here. I see some people are posting the curl command. That's great. Help each other out. Make sure that you register over here. Thank you for the background music. Much appreciated. Let's leave that up for now. Got about another minute. Nice. Can't help but bob your head to this music, right? Now, I have a question. If it's possible to lower the music once I come back in again, it'd still be nice to keep it in the background there. It's cool. But if not, that's okay. Awesome. All right. So keep working on this on your own, but I'm going to continue to jump in here now with our first hint. So one of the great hints that we got is the source code for this. And in case you're not familiar with JavaScript, if you have ever glanced at a programming language at all, or used some other programming language, you can kind of make out what's going on here. And among the files we got is this file called package.json. And one of the things that package.json gives us is a bunch of dependencies. And in this particular case, there's only 3 dependencies. So this might make it easier for us to kind of figure out what's going on here. We have this dependency called Lodash. We have a dependency called Express. We have a dependency called body parser. And that's it. So, you know, file that away. We're going to look at more detail on these. But this may help us figure out what's going on here. Now let's take a look at the source code that we've been given, because this is a rare treat where we're actually given real source code. And in case you're not familiar with JavaScript, I'm going to go line by line, but you could sleuth this out on your own also. So require is we're bringing in a bunch of libraries and scoping them to these variables so that we can access them. And some of them are built in, like FS is built into Node.js. Express is one of the dependencies that we saw. Also body parser, also Lodash. And it has this funny constant. It's just an underscore. Maybe you haven't seen that before, but that's a perfectly valid variable reference. So that's like our handle. So anywhere in the code we see underscore, we know that it's using this Lodash library. We have this options object. It's just an empty object. We're reading in, or I should say the server is reading in the value of a flag. So there's a file called flag. It's reading in that value and it's assigning it to this variable flag. Now, just because I have the source code locally doesn't mean that I can easily hack the backend, but now I know that somewhere in memory is this flag, and that's the thing that I'm trying to get access to. Now, I'm going to skip over some of this code because maybe you're not familiar with it, maybe it's not relevant. Really what I want to start looking at is where some of these requirements are being used. Where's express being used? Where's body parser being used? Where's underscore being used? Now here, this is interesting to me because we know that we're interacting with the echo endpoint. We already saw that from the command line. So I want to focus in on what's going on here. All right, so I have this out object. It's got a user ID and a time, and that is relevant to what I saw over here. User ID and time. Please don't hack me now that you can see my public IP address, but all right, go ahead and hack me. That's okay. So that's part of the output. Now, what I know my goal is here is to reveal the flag. So I'm assuming there's some way for me to get the value of the flag into this output object. I don't know exactly what that is yet, but it's something that I'm working on. All right, here's underscore. When I see this underscore, I know that Lodash is being used. So it's going to merge. Apparently, there's this merge function. It's going to take a request body and it's going to merge it into this output. Now, that's something very important that I'm going to file away. Even if I don't know Lodash and I don't know Express, just the syntax of this is kind of leaking some interesting information here to me. And finally, I have an if statement. And if options flag is set, it's going to include the value of the flag in the output. So now I know the goal. The goal is to somehow get a flag Boolean into options. Now we saw above here, options is just an empty object. So I don't know exactly how I'm going to do that yet, but I'm getting more hints as I go along here. Somehow I have to figure out a way to make flag in the options object and to make it true. If I can do that, then I know that this flag value is going to be part of the output. Okay, before I turn it back over to you, I'm going to do one more thing here, and this comes back to what I said earlier, where sneak is not a requirement, but it will give you a leg up. In fact, I forgot an important part, which was to look at the hint. If we look at the hint in this case is sneak. It's telling me go install sneak and I'll get a good hint. Well, sneak will scan dependencies and scan code for security vulnerabilities. And so if I do a command called sneak test in this folder where I've saved these files, tempting the demo monster, here we go. And what I can see is a whole bunch of issues related to Lodash. And what I see over and over again, there's a couple of different ones, but what I see over and over again is this thing called prototype pollution. Now, maybe you don't know anything about JavaScript and what this word prototype is and what prototype pollution is, but this gives me a really big hint because it looks like there's a vulnerability with Lodash related to this thing called prototype pollution. So this is the point at which you go and get your Google on, and we say prototype pollution. Okay, so we can get some general knowledge, Sneak references up here, but we can do better than that because we actually have some direct references that tell us information about what's going on with prototype pollution or what's going on with this vulnerability in the Lodash that's related to prototype pollution. So let me take a look at that. And one of the things that you'll see when you look at a vulnerability database like Sneak is these proofs of concept. So here is an actual proof of concept that demonstrates what's going on with this thing called prototype pollution. And I'm actually going to put this in here, and I'm going to turn it back over to you in just a moment. But I'm going to put this proof of concept into action here. If I can find my my cheat sheet and copy and paste. Here we go. Okay. So let me put that into action. I'm going to run node from the command line, and I'm going to paste in this proof of concept that was given to me. And let's go through it line by line. So we're requiring Lodash. We saw that before. It's this underscore. And now we're creating this malicious payload. This is interesting. It says __ proto. Maybe you're not familiar with this format, but in the proof of concept, we're being told this is a malicious payload. Then we have this empty object, A. And now we're console logging out a.oops. Well, I wouldn't expect a.oops to show anything because this is an empty object. Then we're using merge. That looks familiar. Didn't we see merge in the source code that's part of this challenge? And what it's doing is it's parsing this malicious payload and it's merging it into an empty object. And then finally, we're logging out a.oops, and then we can see that it works, right? So if I look at a.oops, I can see that we've now polluted it with this message. It works. So that's what prototype pollution looks like. We've polluted this object called A. But one of the things that's often overlooked in JavaScript rather, as relates to prototype pollution, is that it's polluting the object prototype. If you're familiar with strong type languages like Java, we can think of the prototype kind of like the class. So if you're familiar with Java or .NET, it's not exactly the same thing, but it's like the blueprint. So we're actually polluting the blueprint. So if I create a brand new object, it now has this oops property built into it because the prototype for a JavaScript object has been polluted. Okay, so that is a lot of big hints there. I'm going to pause now for another, let's say, 3 minutes, and then I'll reveal the solution. So let's turn the music up, and I will leave this sitting up here. And I got 3 minutes on the clock. Just glancing at the chat here. Good chat. Pro tip, paste the code in chat GPT. It's a good pro tip. Happy to answer any questions if you want to drop them into chat. Happy to drop some more hints as you're working on it. Got another couple minutes. By the way, I don't know if you all have participated in CTFs before. I do with some degree of frequency, maybe, I don't know, half a dozen a year. And I am not a competitive CTFer. I like to get in there and learn some new things. And I am very happy. If I get like 30% of the challenges, I am super happy. Now, I know people that want to solve them all and want to win the prizes. I totally get that. But I find it super useful just to learn new shit. Are we allowed to curse? I don't know. I just did. minute and a half. Anybody solve it? Maybe drop in chat if you've solved it. I see at least one person did. The Tamer and me, similar approach to CTFs. All right, let's jump into our solution. So the big, huge, massive hint that we got here was from our proof of concept, and it's using underscore merge the same way. Oops, I forgot that I already had it running here. It's using, our proof of concept uses underscore merge in the same way that this code is using merge. So it's taking whatever's passed in the body and merging it into the output here. And that's how we get the original thing that we posted through was ping, right? So we could say like, I don't know, let's say greeting, hello. And now we see that that's part of the output. But really, I know also from the code, and of course that time I exited it. I know also from the code that I want to figure out how to get flag equals true into this options object. All right, so based on the proof of concept, I'm going to use this form underscore underscore proto. Now, I still may not have a deep understanding of what's going on with that, but that's what I know I need to do. And I want to make flag true. That's kind of the goal here, right? I want to pollute the object prototype with flag true, because now I get the flag. So now I can come back here to the platform, paste the flag in, and now I got my points. Now, one thing that comes up, and it's a very fair question, we notice that whatever's coming in the request body is being merged to out. So now we have out flag true. Flag true is in here. So how is options flag true? How does that work? Well, if you remember from the example that I showed you, when we pollute the prototype, it's for the blueprint. So I'm polluting the prototype for all objects. So now the out object has flag true, but options now has flag true also, because I've polluted all instances of objects within this JavaScript runtime. So now when it checks for options flag, it's going to be true, and then it adds the flag to the output. So pretty cool. So just in review here, you want to look at all the files you have during challenges, and when you get files, that's like a gold mine. You want to have a look at the code, try to have a general understanding, but really you don't need to be an expert. You can use Sneak to help you solve challenges. Sneak is really good at scanning your code, scanning your dependencies, and giving you feedback about vulnerabilities. And we have a whole lesson on Sneak Learn about prototype pollution if you're interested in learning more about it. It's very particular to JavaScript, but there's a lot to learn there, and it's one of these vulnerabilities that keeps coming back up in the JavaScript world. All right, so I'm going to turn things over to my colleague and awesome presenter, Sonia. If our producer would take my screen out of the stream, I will stop sharing, and then we can switch over to Sonia.
Cool, thanks Micah. That's a great challenge. So let's move on to the second challenge, which is Sauerkraut. So if you go on the challenge page, When you click on the second challenge, you can see that we do have more points here, 150. Also, we can see that the language is different. Here, we're not talking about JavaScript, but we're talking about Python. We also have this sentence, what goes best on a hot dog? I don't know if you have an idea, you can drop it on the chat if you know what goes best on a hot dog. But most importantly, we have the link to the website. So let's have a look at what we have here. So that's the website. There's a flag here somewhere. This is great. We need to find the flag now. And we do have like an input box and a submit button. So usually when we have a website, we're still in the reconnaissance phase. And when we can look at for example, the page source. This is a good example, a good starting point. And here, there's nothing really in the page source. So we can also potentially have a look at the network tab. This also could be a good starting point if you're trying to put some input and test on it. And obviously you can test the input. So you can do as I walk through. So test different kind of input. Let's see if you get some interesting response or interesting hints on that side. So let's see here. Let's try different use cases. Let's try to just click on the submit button and let's see what we get. So here we have invalid base64 encoded string. Okay, that's an interesting, the interesting one. Let's try something else. Let's remove the text here, and let's put test. Let's submit it. Invalid load key. That's interesting. That's actually an interesting response that we have here. So I'm just gonna go to the answer, like, what could you do with this? Any ideas? Not only having this, and while you're actually looking for more hints, for those of you who don't know what is base64, because I just submit here. So here we have invalid base64 encoded, which might potentially be a hint on what we're looking at for the potentially the solution. So base64 is actually a way to represent and encode data in a format that can be easily understood and transmitted across different systems and platforms. It's usually commonly used in computer systems to convert binary data, so which is a sequence of ones and zeros, into text-based representations. So here, apparently, we're expecting a base64 encoded string somehow, which is a good hint. So let's try back removing this, and let's go back to just inputting data. So we have this invalid load key. That's interesting. Let's see if we can Google this. Like, Google is our best friend in that case for CTF. And what we have here. So let's see. Stack Overflow link. Let's click on this one. So, and that's part of the reconnaissance phase and also the education piece, because you might not know everything within the Python programming language. So it's always interesting to know a little bit more about errors, new functions, and all of those. So let's have a look here what we have. So what is it talking about? Pickling. Okay, that's interesting. New words. Pickling. Pickle. Okay, what else do we have? Potentially something that we could have a look at. So let's type something new like Python and pickle. Also, the interesting thing when you do CTF is also to look at the official documentation to have those better understanding the context around those new functions that you might not probably know about. So here we have Python, which is a pickle, which is a Python object serialization. And it's telling us that the pickle module implements binary protocols for serializing and deserializing a Python object structure. So pickling is the process where the Python object will be converted into a byte stream, and then pickling is the inverse operation. But most importantly, we do have a red box here. So the pickle module is not secure, only unpickle data you trust. Interesting. I love this red boxes. This is usually maybe a good hint for us. So it is possible to construct malicious pickle data, which will execute arbitrary code during unpickling. Never unpickle data that could have come from an untrusted source or that could have been tampered with. Okay, that's potentially also a good hint in that way. So here, any ideas what could be the follow-up step? Because I've been doing a little bit of Googling, assuming that I'm not an expert in Python or pickling. I've asked our old friend Google to enlighten me a little bit more on that side. So I think in that sense, we're still in the reconnaissance phase. We actually got a little bit more context, so we know that's Python programming challenge. We're talking about pickling, and we actually want to craft our payload around this. So let's see if there's actually an exploit that we could potentially use here. So what I'm going to do again Python pickle and exploit. Let's have a look at the first one. So exploiting Python pickles. That might potentially be interesting. Cool. So we have David who actually wrote a blog post on that, exploiting Python pickles. How convenient is that? So let's have a look. So it's giving us a little bit more context of what is pickle. So we know this is a module in Python. What else? Oh, also here, the Python module is not secure. So we'll try to temper and use this to temper with this challenge. So let's have a look. What else? Controlling the behavior of pickling and unpickling using the reduce method. Okay, that's also potentially a pointer here. Okay, by implementing reduce in the class, we're going to pickle. Okay, what else? So he's actually created a vulnerable app for his proof of concept. But what we're interested in is actually just the exploit bits. So here we have creating the exploits, this piece of code. So I'm going to give 2-3 minutes for the audience to, if we could also, Micah, if you could share the article, just for you to have a look at the exploit and try to craft a payload based on this one and see if you could potentially have something more interesting than this invalid low key, potentially the flag. I'm just going to look at the chat if there's any question. Cool, thanks, Micah. Yeah, so here what we've been doing is doing a little bit of Googling to understand a bit more about Python pickling. If we could find potentially an exploit, we did here. But now the next step is actually to craft our own payload to actually try to tamper with this website and ultimately get the flag. So let's see if we can do something with this snippet of code. So it's going to leave like a couple of minutes for you to test with this one. So I can see some of the questions. Where can I find the TF? So you'll need to go to this. Micah, if you can share the link, please, on the chat. You only to register, create an account on this one. You'll have access to those 2 challenges. Thank you. And we're actually now on Sauerkraut, the second challenge. I'm just going to leave 1 more minute. If any of you manage to have something with this snippet of codes, any progress, just let us know on the chat. Cool. So let's see what we can have with this one. So usually when you have a proof of concept or an exploit, just gonna like copy this piece of code and moving on to my IDE. Just gonna zoom a little bit more here. What I've done is I've actually copied the code that I found on the article and just tweak it a little bit just to make sure that it actually fits with the challenge. So here what we have, so we've imported the pickle module because we need the pickle module. We've also imported the base64 module and we have the OS module. This is coming from this piece of code. Cool. And we also have this class remote code execution using the reduce function here, and we're using the command like basic who am I just to trigger some response for the application and see if we're getting any response from it. So just like testing with classic who am I, and then we're doing using the pickle dump to actually use this instance of the RC function, and then we make sure that we have a base64 response coming back. So let me check here. I'm just gonna run this exploit, and I should have a base64 string from this one, which is this one I'm getting. I'm just gonna copy this and remove this for you to have a look at. So I've only changed I've changed the commands, obviously, because I didn't want this payloads. And what else did I've changed? I think I've just added the code function at the end here, but it's basically the same piece of code that you can test on your end. So coming back to here, just copy pasting this first one, and I have nothing. That's a bummer. Thought I would have something maybe a little bit more, I don't know, more visual, but actually there's no feedback. Okay. So usually when you don't have the expected results, but you think this proof of concept, yeah, there's no error. This is true, Micah. We don't have an error, so maybe potentially might be working. We're just not using potentially the right module or the right function. So in that case, what I'm going to do is I'm going to look for Python shell commands and get the output, because this is exactly what we want to get the output. So let's see if we can have something around that. So running shell command and capturing the outputs. This is exactly what we want to achieve with this challenge. So let's see if we can use a different approach. So here it's talking about the subprocess check output function. Let's have a look. This is potentially the official documentation. Yes. So here we have run the command with arguments and return its output. This is exactly what we want. So you can see there's a difference between the OS module that we've been using here in the code, and might potentially be able to change this OS module with the subprocess one and using the check outputs. So actually done this before, so just looking at it. So that's the new piece of code that I'm having here. So why should we use the subprocess check output, you might ask? So because we want to capture the outputs, and this module will actually help us to do so. And the difference between the OS module and the subprocess module is with the OS module, it will focus on providing general purpose operating system related functionalities, whereas with the subprocess module, it's specialized in managing subprocesses and executing commands, and we want to execute a command in that case. Cool. So here what I've changed. I'm just gonna lift this. It's better for you to see the difference in the code. I'm just gonna here. So you can see it's exactly the same. We see like pickle base 64. The only thing that we're changing is we're using a different module. So we're not using the operating system one. We're using the subprocess. And here we're actually moving from os.system to subprocess check output. We still want to output the who am I response. So let's see. With this one, I'm just gonna close this. So I'm gonna run this exploit and have a different base64 string. Cool. So I'm gonna try this one and see if we can get a different result. Let's see. Submit. I have a response. Yes, I did use the right module. Okay, so I think I'm on the right track here. Yeah, I'm on something. Cool. So I'm gonna leave the audience trying to tweak and play a little bit with this piece of code. Just gonna zoom a little bit more. So you can open your IDE and just like tweak the code that we did find with David's blog posts using the subprocess one, and try to find the flag. So let's see if we can make progress on that. Just gonna leave like 2-3 minutes on that time. Also, good hint if you don't understand what you have here with the code. A good hint is also to paste it on ChatGPT. This will explain you the what's behind, what's the step by step and every lines, if it'll help. I'm using VS Studio Codes. If that's the question. Yeah. So for those of you who join, what we've done, so we're working on the second challenge, which is called Sauerkraut. We're welcome with this this website. And what we've done, we've tried different inputs. We've managed to get an error message, which was a great hint. We've actually Googled it, and we've also understood that it was about pickling with Python. We also managed to find a blog post, which was interesting because we actually had an exploit that we're using to build our own payload. And also we've seen that we weren't using the right module to output this on the screen, so we've decided to move out from OS and change to subprocess. This is where we're at with this this snippet of code. Might potentially find the flag with this one. Cool. So with this flag, we've actually managed to see that we're a guest on the website, which is great. It's giving us a little bit of feedback. So let's try with a different command. And this time, what we want to do is actually try to list what is behind the website. Let's see if we can have, if we actually find the flag. So let's see what Python 3 here exploits. This is the second one. We're going to get this string. And what I've done here, just going to come back, this one. So the only thing that I've changed, just going to put this in parallel. Cool. The only thing that I've changed here is the ls, just to make sure to list all the files on the website. So let's go back to the website. Let's enter this new string and let's see. So what do we have here? We have app flag, interesting, unicorn config py, and requirements.txt. Okay. We did find the flag. So what is the next step? Just gonna give you 2 more minutes to eventually find the flag. It's here. It's here. It's like we're really near. We're gonna find the flag. So this was the. I'm just gonna leave it here. This was the. That's the code that we're working on. What is the last step actually to find the flag? That is actually a great hint, Micah. Yeah, I'm seeing like great response on the chat. Try it on your own and see if you can get the flag. Let's see who's getting the flag first. Yeah, I can see like really great response here on the chat. Great idea. So try it on your ID. Tweak this snippet of code and see if you can output the flag. Oh yeah, let's have a look at the, while you're trying to solve this challenge, let's have a look at the leaderboard here. We do have a couple of people that actually solve it. Yay! Nice one. We have a lot of people that actually solved the first challenge. Okay, now your challenge is to solve the second one. Let's go. Sure, I'll give you like 1 or 2 more minutes for you to try with this snippet of code and try to output the flag. We're still one step over to the flag, so if you manage to get the correct commands, you'll get the flag. Let's see if there's other people, meanwhile, who did manage to solve it. Cool, I'll just leave 1 more minute. I'll reveal the trick. Cool. So let's have a look at the solution. So this is the solution. Here, how would you actually go by revealing the flag? So a lot of you actually mentioned, and you were right, that we need to use cat flag to actually reveal the flag. The only difference is you have to use an array for this toString cat flag. That's the little trick here. Cool. So let's see. Let's produce the basic C4 for this one. So I'm just going to change the number here. Cool. Copy pasting this one. Just gonna read this. So for those who haven't seen, we've only changed the command to cat the flag. So let's reveal the flag now. Let's change this, and boom, we do have the flag. Let me just copy this and see if it's actually working. Shit. Let's see. Sauerkraut, flag. Boom. I have 150 points. Nice. Cool. So going back here. So what did we learn? So the good news is you don't have to be a Python expert to solve this challenge. You only like really good Googling search skills. But the most important thing here that we've seen from the start is looking at the error message. It actually gives away this little treasure hunt that we've actually started on Google. Also, you can learn more about Pickle and Python with Sneak. We did write a blog post on the ultimate guide to Python Pickle if you want to learn a bit more about pickling within Python. Cool. So I wanted to share a few resources before closing this session. So the first one is the Sneak-Learn platform. So the Sneak-Learn platform is our free online platform where you can actually learn about security. We have a lot of lessons here, and you can filter by ecosystems, and you can see we're covering most of them: Python, Java, JavaScript, and others. So let's see, for example, JavaScript, because Micah mentioned about prototype pollution. And if you're still a little bit confused about prototype pollution, well, we do have one-pagers on this one. You don't need to install anything. This actually, this sandbox, you can test it directly through your web browser and test the payloads. At the end, you have a little quiz as well to validate the lesson. If you don't know where to start, good news, we do have learning path. So if you want to cover the OS top 10 with the latest list from 2021, we do have this. And at the end, you'll have a certificate. Then you can put it on your social and brag about it. We also have other learning paths around Sneak Top 10 and security for developers. The good thing is, if you think it's a little bit too much to digest, it actually keep progress. So if you create an account, it will keep progress, and you can come back at a later time. Also, if you don't know what is next, this is like the Netflix for security. We'll have some lessons for you, recommended for you. So this is Sneak-Learn. Another resources that we have is the Sneak blog. We do have blog posts around prototype pollution if you want to learn more about this, and the Python Pickle vulnerability as well. CTF resources, we love those who might also be aware. So try Hack Me, which is great resources if you want to do a little bit more around pen testing and ethical hacking. Hack the Box as well, and the Oz Just Shop, which is amazing resources if you want to train getting all of these hacking techniques, tools, and methodology. We do have our Snyk YouTube channel. This is where we're hosting all of our series and webinar. If you want to learn more about security, this is great avenue also if you're more of a visual person. If you want to talk about DevSecOps and everything security related, we do have our Discord channel. This is vendor neutral. So if you want to ask questions about CTF, pen testing, ethical hacking, DevSecOps in general, this is a place to be. You can ask your peers. And yeah, just wanted to say thank you for having us today, for attending this CTF 101. I hope you've learned a few things around prototype pollution and pickling in Python. Thank you, Micah, for doing the first challenge. Yeah, hope you all enjoy it. Thank you.
Yeah, thank you so much for hosting this. I think based on what I'm seeing in the chat, everyone enjoyed it as much as I did. I think for people that want to get into CTFs, honestly, it's really scary to do them. I started doing CTFs a couple of years ago, and it was honestly very scary not knowing what to do and what is a flag and stuff like that. So thank you guys both so much for doing this. I appreciate it so much, and I know everybody in the chat also really enjoyed it.
Thanks. Thank you.
Cool. Thank you all. We'll talk soon.
Thanks. Bye.
Bye, everyone. Bye.
All right. So that was the first workshop of the day. We have a few minutes. We're going to quickly drop into a quick ad. It's not going to be one of those ads from Twitch. I'm sorry for those of you that were stuck on the ad. I did not know they were running. I promise. We removed them. It's not going to happen again. But we're going to drop quickly into an ad right now. And we're going to come back in the next couple of minutes with Devil Fox from Halborn to look at some smart contracts. So stick around. We'll be back in maybe more than 5 minutes. We'll be back.
Snyk, we often talk about our industry-leading security intelligence. But what does that mean? It means that we have top researchers using cutting-edge technologies and community collaboration to curate some of the most up-to-date stores of vulnerability data. We have teams working on the Snyk vulnerability database, filling it with hand-curated content and enriched metadata so you can accurately identify risk, learn about new vulnerabilities faster, and fix them quickly with actionable context. We have teams using machine learning and AI to build our Snyk code knowledge base to keep vulnerabilities out of your proprietary code. And we have teams that are staying on top of the latest cloud and IAC misconfigurations to build our robust unified policy engine. Then we combine all of this intelligence to power the Snyk platform, making it easy for you to secure your applications.
This is not a glitch. Want to be more than a spectator? Want to win prizes, gain glory, and be a part of an international community of bug hunters? The world of bug bounties goes deep, but we all started at the surface. Check out ProjectCircuitBreaker.com and enter Intel's epic universe of bug bounties and hacking challenges. There's so much to explore.
Truffle Security sponsorship gets you a 5-second ad. 5 seconds? The fuck?
All right. We have a few minutes before our next presentation goes live. Chat, what did you think? Everybody watching, I know there's a lot of you guys in the chat watching. First of all, if you're new to the stream, welcome. Welcome to the channel. And if you've watched me live, welcome back. If you've watched me live in the back, welcome back. What did you all think so far? Should we do more of these CTF workshops? I personally think it's it really helps with the fear of doing something new. But I also want to hear from you all. What did you guys think? Yes, hard topic. Yes, do more. Yes, a lot of CTF. 100 hands down. Definitely. Yes, do more. Yeah, I think I'm going to try and see how we can do more of these. I never thought about doing, honestly, something that's really CTF focused like this. This is our first time. And then, again, if you've watched NahamCon for the last 4 years, this is our 4th year. We have never done a never done a workshop like this. It's always been a one day. So this is something new we're trying. It gives us ideas of what to do for next year. So I'm excited that people are enjoying it. So if you are, thank you so much for sticking around. We still have 3 more workshops coming up. The next one is about hacking Ethereum smart contracts. I know smart contracts with a lot of the offensive security professionals and hackers has been a very popular topic. So we're going to kick that off in just a sec. And next, after that, we're going to have, I'm trying to think of Argari FR, Nicholas. He is, I was trying to think of his handle. He's doing a bug bounty focused Burp Suite workshop. His course that he does on Burp Suite is one of the only certified courses that's actually certified by Portswigger, and he will also be live here in a couple of hours. So that one's coming next, and then we're gonna wrap it all up with Tiberius doing his Prevesk stuff. All right, we're gonna welcome our next speaker, Devil Fox. I'm gonna give him 1 second to turn on the camera, or if they have anything to share, we're gonna just welcome them to the stream in a couple of seconds. Are you all ready in the chat? Chat, can I get a bunch of readies in the chat before we bring on our guest? You guys ready? All right, let's invite our guest. Hello. Welcome to the stream. Welcome to the conference.
Hello, this is Istvan from Helborn. Nice to meet you.
Nice to meet you as well. I'm going to quickly let you share your screen, and then I'm going to let you take over the stage for the next hour or so.
Cool. Let's start it.
There we go. I'm going to quickly add and then remove.
All right. I hope you can see the screen. So I'm not a PowerPoint expert. I present this on Linux. So sorry, I will not go full screen. Okay, so let's talk a little about our agenda. I will start a short theory part, and then we will do some hands-on. But 1 hour is very short, so I will skip the chit chat. This is me. Yeah, I do cybersecurity stuff. And yeah, let's jump into web versus Web3. So I think you are maybe familiar with web applications, but smart contracts are a little different. There are vulnerabilities that are common in web applications, but there are a lot of new ones. And smart contracts behave a little different, and that's why they need to be approached using a different ways. Like code is low. If you have a web application and something is messed up, you have a bank, you can just edit the balances, modify the code. So easy, nothing serious. But for smart contracts, code is low. So if there is some issues, then you may not be able to change it, and the attackers can just exploit it forever. And I think the other interesting thing is for web applications, it's really hard to make money from it for black hats. They can steal credit card information, personal data, and sell it on darknet, but it's not an easy process, and that's why they try to get gift cards. But for smart contracts, often most of the applications are DeFi applications, meaning they handle tokens, funds, and attackers can just target that directly and just transfer that from the contract to them. And it's much easier to whitewash money on a blockchain using these mixers. I'm not an expert in this, especially not in a web too, but yeah, just believe me. So yeah, and there are a few very interesting vulnerabilities. I think one of them is front-running vulnerability. I will try to explain this. Okay, so let's say that imagine you are using a marketplace, a smart contract, and you find an NFT listed for a price you are very happy. You decide to buy it. On a traditional website, you just click buy, and that would be the end of it. So, but in blockchain, things work a little differently. When you buy, you are actually creating a transaction that goes into the public mempool of pending transactions. And this transaction says something that I want to buy this NFT. But what if it does not specify the price? So then the seller, who is able to see this pool of pending transaction, can find this buy transaction and quickly create a new transaction to update the price of the NFT to be higher than what this was originally listed for. So after that, the buyer transaction will be executed, and the poor buyer will pay more money for this NFT. So this is something new that was introduced in smart contracts. And other interesting vulnerability is reentrancy vulnerability, and we will see an example. So I will not explain it now. Okay, let's talk about vulnerabilities. So these are the vulnerabilities that I'm talked about. This is a reentrancy attack, front-running attack. There are buffer overthrows everywhere in the last 20 years, I guess, or 30. So nothing GUI, vulnerable components, bad randomization, bad calculations. It's just the common things. So let's get hacking. I think it's not easy to start, and this workshop will be about teach you the basics. Always the first step is the hardest, so I can now show you easy ways to just check smart contracts and test them. And this will be our tool set. Zion is a great Linux. It's developed by Halborn, and it has all requirement tools installed for it. So if you're a beginner and don't want to try hard by installing the multiple packages that you need and tools and configure them, believe me, it's pain in the back. But Zion has all it, so perfect for beginners. But if you are super experienced, you can just try Ubuntu or Debian or any other Linux. And we will also use the Infra and Etherscan services. It can help us to just simulate real environments. So this is Zion. And also the main point of contact will be this GitHub repository. So please, someone post it in the chat and open it. It has some guides. It helps you to set up Zion if you have not done it. It has a manual installing section for Ubuntu. It also tells you how to set up Infra and Etherscan for this workshop. So just open this. It's István Baum, NahamCon 2023. And I hope this will help you even just recreate the exercises after the workshop. And as I said, we will also use Infra and Etherscan. Here you need to create accounts, but actually you do not need to do this to follow the CTFs. It's not mandatory, but if you want to test contracts from the mainnet, then you need to fork from the mainnet, which means that you can simulate these contracts in a local environment. When you request real data from the blockchain, it reads using this data, using these services. And when you write into blockchain, you write it locally. So this is very good for testing. But I will show you in practice. So what you need to do is just open the console. And there is a few commands that you can just execute to just clone this repository, and we will start compiling the project. Okay, so I just opened this in code, and I recommend you to also do it. Code is also pre-installed, Codium in Zion. And what we will do is just open this Brownie folder. It contains the project. And in the package JSON, you can see the dependencies. If you open the smart contracts, you can see that they are using these OpenZeppelin external dependencies, and that's why we need to install them. This is the npm install command, and it will take a little time. So I recommend you to just execute this. And now if you have any questions or problems with this installing, you can ask in the chat. I will start checking these contracts and tell you what are they doing. I think there will be a recordings on YouTube, yes. So yeah, what will we do in this workshop? Just check this Brownie folder. This is just some general Brownie project folder. And you can see that here is a very basic example smart contract hello world. So what you see that this is the line where it's specified which compiler should this smart contract use. This is an example function, and just print some data. You can see an exploit folder. We will use this later. You can see a mocks folder. What are mocks? Mocks contracts are test contracts. They simulate the behavior of real contracts and used to make testing easier. There is a mock ERC20 contract. It's actually a token standard for Ethereum-based smart contracts. Tokens are digital assets that can represent a variety of things, such as digital currency or staking company. So it's like gold in online games. And ERC721 is the NFT standard for non-fungible tokens. So they are like items in online games. Maybe two items is very similar, but they have their own properties. For example, the owner. And in the vulnerables folder, you can see 3 smart contracts. They are very vulnerable, so I do not recommend you to deploy them on mainnet. But they are fun to exploit. We will try the tickets smart contract. And if you up to the challenge and would like to try the other 2 after the workshop, I recommend you to try it. And I will show you how to test contracts and how to interact them. So let's see that. Okay, so everyone, get ready. Install is ready. If you check that there is node modules, npm install the packages here. And as I said that, let's start with the tickets contract. Actually, if you check the auction contract, it says that it imports this Open Zeppelin library. And in the Brownie configuration file, you need to tell the Brownie framework where are these dependencies. So if you try with other contracts, you need to configure this. But maybe you can read more about this in the Brownie tutorial linked on my GitHub page. So tickets. Oh, and there is a scripts folder. This is very important. So we will use these scripts to test the contracts. What you need to do is, let's simulate the Ethereum blockchain locally. So if you want to follow this part of the exercise, you need to just create an account in Infura, or you can just watch me doing it and do it later. It will be not required for the CTFs. You need an API key, and I should delete this after this workshop. You should keep it secret. If someone gets it, they can't really do too much harm with it, but it's a bad practice. And they can just eat your quota because it's a free service. So if you run this command, you should see something like this. It says that the blockchain simulation is running locally on this port. And from the same folder, you need to just execute Brownie. And now you can see that Brownie framework compiled these contracts. Here are the vulnerable contracts too. And now I show you how to interact with these contracts. It's in the scripts folder, contracts file. And what you need to do is just copy paste these things. But not all together, just the parts you need. And this first part will just initialize the important parts. So what are we doing here is just, this is a helper function. Oh, you need to put your Etherscan here, key here. So this is my Etherscan API key, and I just put it here. And actually, you can just copy paste this again. Doesn't matter. Okay. So the first thing first, these are our test users, and you can check the balance of a user using this command. Actually, it does not have this much Ether, because Ether has 18-digit precision. So if you just divide this with this precision, you see that this is actually how much Ether this user has, and these are the further digits used for precision. And we can transfer this Ether to another test user. So this is the destination, and this is the amount. So remember, this is only for testing. So actually, it will not change the real blockchain data, but you can do a lot of interesting stuff. And this is how you can deploy a contract. As I said, this is some just test contract. You can, this is the name parameter, and this is the symbol. So tokens are a little different from the native Ether. It's also a currency, but a token is like Dogecoin, while Ether is the native Ethereum. So if you are interested, this will be a contract. You can check the functions of a contract, like using the signatures call. You can see that these are the functions that this token contract can do. For example, you can check the balance of a user, because this is a mock contract. You can check it. This is the mint function. You can create test tokens with it. It's a public function, so anybody can use it. And this is for testing. In real contracts, they just restrict it later. I think, yes, there will be a recording later, not for about this workshop, but I think they made some videos about. So let's mint some test tokens for user one. So if you run a transaction, you can also tell, can use additional parameters. For example, we can tell that this transaction is from user one. And now we can just check the balance of user one. And there are very interesting transactions. For example, you can use the approved transaction. Approved transaction is working like that. The caller authorized this user to spend this much tokens on behalf of them. You can use a transfer from function to transfer from someone to another address. For example, from user one, let's transfer to user two. And if we send this transaction from user two, then it will revert, which means that it will just send an error, and actually no tokens will be transferred to user two. But remember, we approved the token transfer for user 3, so this should work. And you can see that user 2 received the tokens. And this is because this approved transaction. This is also something new, or it was a little complex for me, but yeah, you can actually approve contracts or users to transfer your own tokens. And some of the smart contracts are working like that. Some of the smart contracts are working like that. They transfer your own tokens. So you are not the one who transfer it. Okay, I will try to increase the font size. Maybe it's too small for you. And all right, I hope it will be easier for you to follow it. Okay, so this is an example ERC20 contract, but let's do something interesting. If you are familiar with the Bored Apes Club token, it's an NFT. And you can do something like that. You write the name of the contract and Etherscan after it, and just find the Etherscan page of a contract. And you can see that this is the address of the contract. If you go in the contract tab, you can see the name of the contract. You can see the source code of the contract. This is something new because for normal websites, you do not get the source code. But for smart contracts, you can just get the bytecode for every contract. And sometimes, or most of the times, even the source code is public and it's uploaded to Etherscan. So what we will do is just use this Bored Ape Yacht Club locally. And to do this, we can use this function, which is in the beginning of the contract spy script. It actually uses Etherscan to get the interface of the contract, because we are using Infura. So this is Infura. We are using Infura to just copy, Infura is a service. When you request the data or query a data on the blockchain, you can use it using Infura and you will get the data. But if you want to write it, you will, as I said, write locally. But even if you get the data from the blockchain, you need the interface of the contract, because you do not get it with Infura. And that's why we need Etherscan. And using Etherscan, we can get the interface of a contract. And after that, we can use it locally. So to use this, we need the address of the contract and the contract name, which is in Etherscan. And after that, we can just use this Bored Ape Yacht Club contract locally, just like the real one. So we can check that who owns the lead token. This is the token ID. And you can see that this is the address who owns the lead token. And what you can do here is to just transfer this token from the owner to you. So transfer from is the owner of this token. Let's transfer it to user 1. This is the token ID. And if I transfer it from user 1, you see this error message. It says that the caller is not the owner, because in the mainnet, in the real blockchain, you can only send a transaction with your private key, which is this. But actually, in Brownie, locally, you can impersonate any user. So you can impersonate even the owner. And if you impersonate the owner, you can just send a transaction with them and, for example, send your tokens to you. Of course, just locally, but it's working. So this is the token owner, and we can check that if it's user 1, and indeed, we were able to transfer it. All right, so this is an NFT contract. Someone asked me what this contract do. So if you are familiar with NFTs, Bored Ape Yacht Club is a very famous NFT. So it's like digital art, or as I said, NFTs are like items in games. So you can just, maybe they are just a picture, someone called them JPEG, but they can have some utilities. For example, if you have a NFT, maybe you can use it in different programs, for example, games, or maybe it has its own value. Yes, that's it. Non-fungible token, someone write it. So you can read about it. Just think about it like a contract, like a program. And what is important here is that in this local environment, you can just impersonate any user. You can just copy the contracts from the production mainnet, real ones, and try them out in a local environment. And this is very good because it's really easy to test them locally. So if a hacker wanna exploit a contract, they do not need to, attack them like a website, like trying things. But they can try it in a safe place, maybe with lots of debugging enabled. So I think it's much more fun testing a smart contract than a website, which was really painful because it was boring for me after a time. All right, so if you want to recreate these exercises, just try these contracts. Just remember you need this Etherscan key, update it with yours, and just execute it. And so Brownie is a very cool tool, but sometimes it crashes, sometimes it stales, and that's why you need just Control-C and just exit from it, exit from Brownie if there is some errors, and you need to just restart it. It's painful, but I think it's just the cost of this interactive tool. So I just restarted everything, and now I lost everything, every previous state, but it doesn't matter much. If I really want it, I just copy paste it from here. So this was just the presentation to show you what are the common tools, how you can just copy contract locally. Now are starting the interesting part. We will check the tickets contract. So when I test a contract, it's really important for you to just understand how it works and what can it do, what should it do. So just check this ticket Python file in the scripts folder. And as in the previous version, we just copy paste the beginning. Here, I created a snapshot. Snapshot is also a very good tools. You can just jump back to this state anywhere in the code, so it's very good for testing. So what we did here, we just deployed this tickets contract. So the deploy operation is working like that. First, you specify the name variable. You can use this contract after using this name variable. And this parameter is the deployer. You can use any user here, user 1, user 2, but deployer is just the first user for me. And after that, this is the contract name. Let's open the tickets contract. You can see that it starts like contract tickets. So you need to just copy paste this name there. And if a contract has a constructor and it has parameters, then you need just add the parameters after this. This is the first parameter, this is the second one. But here, the tickets contract does not have any parameters, at least the constructor. And this is the second transaction that we will execute. Transactions are like functions. So we will initialize the contract. Initialization pattern is something like that. First, you deploy the contract, and after that, you just set up the most important variables. So you can just copy paste this part and execute it. So what happens here? This is the initialize function. There is an event name. That's the name of this concert or conference. This is the price of one ticket. Tickets, the number of tickets to sell. So if you only want to sell 100 tickets, then you will use 100. And closed is the sale duration. So it's in seconds. So if you check this, it's 1 week long. There are some helper variables in my Python script. So Python is so awesome. This is one of the reasons I like Brownie framework, because you can just use any Python stuff here. So here we just initialize the contract. And after that, we check the user one balance. You can see that user one has 100 Ether. We can just print the event name. You can see that this is the smart contract variable. These are the functions. So it's very intuitive to use it, especially if you are familiar with programming. So in here, we just buy 5 tickets. And if you want to inspect a transaction more and print debug data, then you can just check the info of a transaction. You can see the transaction hash and from to. So this will be the contract address. This will be the user who called this function. And if there are events in the contract, then you can watch them here too. What are events? If you check the Okay. Yeah. Yes. This is the buy transaction, right? Yes, buy transaction. So what is an event? You can see that we emit an event at the end, and events it can be used for debugging. You can just shut out some data. So you can check that how this function is working. There are some require statements. If a require statement is false, then it will just stop with an error message, and any modifications in the contract will be reverted. So this can be used for error checking. And after that, we just increase the this array for the user. We can check the balances. You can check here that user just lost 5 Ether. The ticket contract just get 5 Ether, so it's working like expected. And if you check the buy transaction, here is this payable word, which means that keyword, which means that this function can receive Ether, and it will be this much Ether. So this is the price, and check it if this Ether is enough, and if not, then it will revert. So this is how it receives it, and there is a refund function. And the refund function uses this message sender call to send back the Ether to the user. And it decreases the quantity. We can try it. We refund 1. You can check the info of the transaction, print out the contract information. So user just lost 1 ticket, but the add balance of the ticket contract just decreased. So everything is working fine. This is a safe contract. And in Brownie, you can also just jump in time using the chain sleep and chain mine commands. And this is important because you can't sell or the event will not end before 1 week. And we can just withdraw the money from the contract with the deployer. And you can see that the deployer just received the Ether. The ticket contract has no Ether. So this is the intended behavior of this contract. And now our job is to just try to find vulnerabilities here. And because we have a very little time, I will show you some vulnerabilities in here. And you can just check the other contracts and find vulnerabilities there by yourself. So the first vulnerability is in this initialize function. And you can try it. Here we call this function with the deployer. And even if you do not understand smart contract code, you can try it. What happens if you call this function again? And actually, it's possible to change the contract variables. So you can just increase the ticket's price. And you can just extend the duration, which is might not a very decentralized thing. But actually, there is a bigger vulnerability here. And that's it. Everyone can call this function, even after it was initialized. You can try it by just replacing deployer to user1 and see that if you can change the contract data with this function. Why is it working like that? Because in smart contracts, everyone can call the functions. So everyone has authentication, not like in the websites, but the function should add authorization checks. So this function do not check if the caller is the owner or the deployer or someone who authorized to change the data. And if you check the withdraw function, then you can see that it has this keyword only owner, which is a modifier which is actually encapsulates the function with this check. So if you try to check the withdraw function and call it with user1, you will get this error message. But this is missing for initialize function. And actually, this is a very common smart contract vulnerability that the developers sometimes forget to add this check or some authorization check for high privileged functions. So another interesting vulnerability is a reentrancy attack. And it's working like that. If you refund a ticket, then you can see that we send back the header to the user. And actually, if you have a smart contract, and I created an exploit contract for this, you can have these fallback functions. And you can implement logic in these fallback functions that are working like that. If this contract receives header, then this function will be executed. And if you see that, this line will send back one header to the contract, and that contract can execute the refund function again. And that's why it's called reentrancy, because in the middle of an execution of a function, it just calls the function again and again and again until it's good for the caller. And after that, the whole execution just finishes. So this contract can be exploited that way, that there is also a tickets reentrancy exploit Python script. You can use it to test it. So I will write chain reset, and this will just erase all stuff what we did locally. So this is a very useful debugging function, and just deploy everything again. And you can see that, let's go step by step. So until here, everything is working as expected. Someone buys 5 tickets, so the contract has some funds. Then the hacker deploys this exploit contract, and we check the balance of the hacker. Then the hacker calls this exploit contract, and we check the balance of the hacker again. And you can see that here the balance of the hacker is 100, and after calling the exploit is 105. So what happens? The hacker deploys the contract, and here the contract saves the ticket contract address. Then the hacker just calls the exploit, and in the exploit, the contract buys 1 ticket. Then after that, refunds 1 ticket. The contract can buy a ticket using the ether sent by the hacker in this transaction. If you can see that here, the hacker also sends 1 ether. So what happens here? In the refund function, this will execute it, and everything is right. The hacker, the contract has 1 ticket, so it can refund it, and this will be executed. this line, it sends back one letter, and after that, this external receive function will be executed. It checks that if the contract that called him has more than 0 balance, then just refund again and just re-enters in the same function. And then the check's happening. Oh yes, the hacker still has the ticket. Just send back one more ether. Why? Because you can see that only after the send is the quantity decreased. So it will be still 1 because it will not subtract this one. So this will be executed again and again. And in the history area, you can just check the last transaction with this. It's Python. And you can see that the ticket refunded event was emitted multiple times. So you can see that this is emitted here. So this is also proof that this function just executed more and more and more and more and until it had funds. It's very funny. And you can see that this array contains how many tickets a user have. So the hacker will have 0, because remember that not the hacker bugged the ticket, but the contract. And the exploit contract has this many tickets. Why? Because there is a buffer underflow here. So if you just subtract 1 from 0, then you will get the maximum of that variable. So actually this is happening because this contract was written in an older type of Solidity, where these underflow checks are not used by default because more operation costs more gas, and that's why they just wanted to make it default that it's more cost effective. So in the latest version, it's working like this, but still there are places where this can be just exploited. I think reentrancy vulnerabilities are very cool. All right, so there are also lots of little things. For example, when we buy a ticket, it doesn't check if the sender sent more money, which is not really user-friendly. So nice contracts just send back the extra amount to the buyer. So yeah, this is the tickets contract. There is an auction, and there is also a very interesting vulnerability in the auction contract. I want to give you a little spoiler. It's in the bid function, and it's very similar to the reentrancy attack. It's like when someone bids on an auction item, the previous bidder will receive the Ethereum from their bid. It just sends back to them. And just think about that. What happens if the bidder is a contract? Then again, the contract can use a function like this, and it can revert in it. And if it reverts, then it prevents the new user to bid on this item. So after a contract is bid on the item, no one else would be able to. And it will just win the auction. So this is something that someone who is not really familiar with smart contracts may miss, but it's a very interesting vulnerability. So if you have questions, I can answer them now because we have a few minutes, and you can try to check the other contracts. So there were a question about what is a fork. So when you see that this command, so we have this fork parameter, and forking is like that, creating a copy of the blockchain. So when we test, we can't really use the real blockchain because it would be just too destructive, or maybe the contract is not even on the real blockchain. But using forks, you can just create a copy locally. And this is working like that. If you need a new data, then this infra API will get you the data. But if you want to write something, then it will be write locally. So you are working in a separate test environment, which is very similar to the real one and behaves like a real one. And this is good because sometimes the contracts that we test are using external contracts. And for example, Uniswap, or this Bored Ape NFTs, or Dogecoin. And if you want to just simulate a real environment and do not use mock contracts, which are contracts for testing, then you can just use the real ones. But if you just use a local environment without forking, then you were not able to load these external contracts. You need to create them like I did for these mock contracts. So for the CTF, it's not required to use a fork or that fork parameter. You can just omit it. Just delete this and it should be still work. So someone asked that is Web3 similar to smart contracts? I think it's maybe Web3 is more broad, but yeah, Web3 is more about blockchains and smart contracts are running on blockchains. Smart contracts like web applications, just they are running on blockchain. Okay, someone asked how to perform fully dynamic testing of smart contracts deployed on the mainnet. So using this, as I said, that this is the contracts Python file, and here we use this Bored Ape Yacht Club NFT, and we just loaded it. And you can just load any contracts that are on the mainnet. And after that, you will be able to use the functions. You can impersonate users. So actually, this can be used to just test contracts on the mainnet too. And what usually I do is just use Etherscan and try to find the contract address. And if you are lucky, here is the source code. If to able to call the functions, you need this contracts API, which is like the interface. And but if there are no interfaces for the contract, you can also just add them manually and you use that to just call these functions. So yeah, using Brony, you can totally test contracts already deployed on mainnet. Okay, so everyone, I recommend you to just check this repository mine, and you will find a lot of useful stuff there. But if you are more expert and want real challenge, then Halborn, CTF, GitHub. Yes, so the Halborn, the company that I work for, is a blockchain auditing company, and it has lots of smart contract CTFs. They are not easy but I think they are really fun. Yeah, if you have time and would like to try them, I recommend you to just try it. And I solved them using Brownie, at least the Solidity one. So someone asked that is Web3 equals smart contracts. Actually, there are a lot of blockchain technologies like Solana, Substrate. So Solana smart contracts called programs, for example. And if you want to learn hacking, I think you need to learn smart contract development. You don't need to be expert, but yeah, just think about that. If you want to break something, it's a good thing for you to know how to build. So how at least understand the code, how is it working? But you don't need to know too much because, as I said, you can test that interactively. And sometimes I test a very complex contract, and it has a very complex code, and I just test it like black box without understanding the code, or first without understanding the code, and see that, oh, what happens if I call with this user? And yeah, usually during audits, we get the source code of the contracts, but as I said, that most of the contracts have their source code uploaded to Etherscan. So remember, this is the Etherscan page. You can just search for contracts. You can search for addresses. And yeah, in the contract section, you can just read the source code of the contract. So if you're familiar with it and you know how to develop a smart contract, it helps a lot. So someone asked that any good resource for learning smart contracts pen testing as a beginner. I really recommend you to just learn smart contract development, and after that, check just public reports. So we are very lucky because in the blockchain industry, reports usually used as a marketing tool too, and transparency is very important. So there are a lot of reports that are published. There are CTF platforms that publish the vulnerabilities. So you can learn a lot by following others and just read their pen test reports and try to recreate them, try to understand them. Lots of reports of Harborn is also uploaded in the repository. And I also recommend checking the Harborn site because it has very nice resources, blogs. We have a lot of interesting exploits explained by our professionals. So this can also give you some high-level overview of typical vulnerabilities. And after that, you can research these topics. But yeah, I definitely recommend you to just learn the basic of smart contract development. It's not hard, and this is also something that it was hard for me to learn it because, you know, setting up an environment and testing and how to build it, how to try things, it's hard. But using Brownie and Zion, it's very easy. So we just help you with this first step. And I think using this Brownie framework and Zion, you can just very easily learn how to build smart contracts and test them. And if you are pen testing professional, familiar with red teaming, I think it helps because I think the mindset is what the most important. This is a very, very fast and always changing industry. I always think about myself as problem solver. I need to learn new things every day. And so if you are more experienced, you used to learning, then it definitely helps.
All right. Thank you so much for the presentation. I really appreciate it. I'm going to remove your screen if you don't mind really quickly. Thank you again for doing this. I really appreciate it. Thank you everybody for sticking around and watching this. I think we got to all the questions. For people watching this, if they want to get in touch with you, where can they find you? I think you're on Twitter. We have you on the website. Is that a good place for people to reach out?
Yeah, you can find me on Twitter, and I'm happy to help everyone who are reaching out. So thank you very much for this opportunity, and I hope you enjoy the workshop.
Thank you so much. Thank you so much for doing this again. We're going to take a quick break. And in a few minutes, we'll have our Burp Suite workshop coming up in just a few seconds. So we're going to take a quick break. We're on a quick ad. And in just a few minutes, we'll be back to doing our workshops again.
At Sneak, we often talk about our industry-leading security intelligence. But what does that mean? It means that we have top researchers using cutting-edge technologies and community collaboration to curate some of the most up-to-date stores of vulnerability data. We have teams working on the Sneak Vulnerability Database, filling it with hand-curated content and enriched metadata so you can accurately identify risk, learn about new vulnerabilities faster, and fix them quickly with actionable context. We have teams using machine learning and AI to build our Sneak Code knowledge base to keep vulnerabilities out of your proprietary code. And we have teams that are staying on top of the latest cloud and IAC misconfigurations to build our robust unified policy engine. Then we combine all of this intelligence to power the Sneak platform, making it easy for you to secure your applications.
This is not a glitch. Want to be more than a spectator? Want to win prizes, gain glory, and be a part of an international community of bug hunters? The world of bug bounties goes deep, but we all started at the surface. Check out projectcircuitbreaker.com and enter Intel's epic universe of bug bounties and hacking challenges. There's so much to explore.
Another 5 seconds to talk about truffle security. Huh.
we are halfway through the day with day one of NahamCon. Let me know, chat. How's everyone doing? Are you enjoying the event? Are you excited about our next 2 workshops coming up? And are you guys going to come back tomorrow? That's what I wonder. Who's coming back tomorrow for more of the conference and more of the talks? Kind of in the chat. Wonderful. Yes, a lot. Yes, sir. Me. Shout outs to you guys for coming back. Ashwin with me. We're coming back for sure. For sure. Hell yeah. Anyone doing the CTF? I know the CTF is probably one of the most exciting parts of the NahamCon and one of the things that we put a lot of time and effort into. So I hope you guys are also enjoying it as much as we are. All right. I'm going to shut up and bring our next speaker up. Give me 1 sec. I'm going to bring him up. All right. You guys ready? Let's do it.
Good morning, good afternoon, or good evening, depending on your time zone. I'm Nicolas Grégoire, and I'm glad to give this workshop for NahamCon. I will share my screen. Here we go. And this is my slides. Okay, so let's start. So I will discuss Burp Suite Pro. That's probably not very surprising if you know me. And we will discuss mostly automation tricks. So first, I will introduce myself. I'm Nicolas Grégoire. I'm French. You probably already noticed my accent. You can find me on Twitter. My personal account is agari_fr. My account dedicated to Burp is Mastering Burp. And also, I have an email address like everybody else. I founded my own company called Agari like 10 years ago, a little bit more. Currently, it's mostly dedicated to trainings, like my Mastering Burp Suite Pro training. And I also do a bit of pen testing and bug hunting on the side. I'm an official Burp Suite training partner for Europe, and I have customers all over the world, mostly in Europe, North America, and wherever customers are looking for this kind of training. I have around 100 students per year for the last 10 years, so that's quite a large population. Ask around, you probably know some of my former trainees. So what is the plan for today? First, we will install the test bed. In fact, the challenges I will go through during this workshop are based on public containers I published earlier this week. So you will be able to reproduce all my testing directly on your side, on your own targets. So that will require Docker, but that should be very easy to set up. Once we have a working setup, we will discuss several scenarios. The first one is how to manage CSRF tokens in Intruder without needing any session handling rules. So that's a trick which is very useful. Quite often you want to brute force a value or go through a word list, and you don't want to create a dedicated session handling rule and possibly macros, and that's doable in Intruder thanks to recursive grep. So I will first introduce recursive grep. Then we will see how to use it to manage CSRF tokens. After that, we will switch to session handling rules. First, I will introduce them, define the terminology, and explain the default behavior. And once we are okay with the basics, we will do session management first for web applications. So in web applications, we will rely on cookies in order to manage sessions. And so the goal is to have a very generic way to handle CSRF tokens. So our strategy can be used in intruder, in repeater, even in scalar. And after that, we will turn our attention to web APIs. And the big difference between web apps and web APIs is that in APIs, most of the time, you don't have cookies. So we will have to manage HTTP headers in order to carry our authentication token. So here we'll have several scenarios. First, we will use a static header in case your token is valid for, let's say, 2 hours, 4 hours, or even more. Then we will discuss dynamic headers, where we will fetch a new token for every request. It's not the most elegant solution, but sometimes that's all you need. And the last setup will be based on cached headers. So if we consider JSON web tokens, for example, they have expiration date, and we will rely on the validity of the token in order to renew it automatically just before its expiration. Okay, before we start, some extra details. Last month, I published a 30-minute talk during NorthSec, which is a very good, high-quality conference and CTF in Montreal, Canada. So that's 30 minutes of tricks. There's no overlap between the current workshop and the talk I published last month. You can get the slides online, and the video of the talk itself is also available directly on the NorthSec channel on YouTube. So what is covered in this talk? It's like keyboard shortcuts, how to avoid scrolling, presenting a few extensions like Turbo Intruder, no, not Turbo Intruder, Hackvertor, Piper, etc., etc. So feel free to give it a look. You may find some interesting content. And regarding this workshop, the slides are already online, so instead of just reading the materials, you can download your own copy of the slides, and that will be useful during the challenges. So you can copy and paste the comments or regular expressions or whatever directly from the slides instead of having to type them. Okay, we are done for with the introduction. First, we will run the containers hosting the challenges. So there's 2 containers. Mini app is a very, very basic PHP application with 2 challenges, one of them being a form protected with CSRF tokens. And Juice Shop, that's the official Juice Shop product. So that's a vulnerable web app with some minor modifications. The most critical modification in our case is that I lowered the validity of API session tokens. So usually they are valid for 5 hours, and in my own version, they are valid for 2 minutes, which is very useful when we try to validate if our automation works well when the session expires. So first, we need to download the containers. Here we go. And I will download the second one. Perfect. And now I will simply run them. So if you're not comfortable with Docker, I will detach the process, so it will go in the background. And here I will map my local port 9081 to port 80 of the container. Here we go. And for Juice Shop, it's very similar, and we are binding port 9082. Perfect. So now we have 2 containers running. Now we can access both of them. For example, as you can see, it works. And the second one works too. Perfect. So now we have a running testbed. Let's see. Let's see them directly in Burp. So regarding Burp, I'm running Burp Pro. If you are running the community version, that should be very, very similar. So that's a mini app. So as you can see, there's 2 challenges. And let's open Juice Shop. Perfect. Okay. So everything is running. We can move on with technical content. So the method I will introduce works exclusively in Intruder, but doesn't require any session handling rule. So it will rely on recursive grep. So if you have never heard about recursive grep is a payload type for Intruder, and it's a payload type that will provide payloads extracted from the last received response. So that will be very useful for CSRF, and technically that's quite easy to configure. As you can see in the slides, that's the configuration window for this payload type, and we have 3 settings to set up. The first one is O to start, which is the initial payload. So here in this example, the value is 1. Then O to progress. So here we need to select one of the configured grep extract entries, and this grep extract will pick some value from the response and the corresponding value will be the next payload. And finally, given we have a recursive processing, we may decide when to stop. So here that's somewhat magical. There's a button called stop if duplicate payload found. We will see later that's probably that all you need is enabling this setting by checking the box. So grep extract, if you are not using it, is a very, very useful feature of Intruder that will add a new column to the result based on the extraction criteria we defined. That's very useful. For example, let's say we have an IDOR vulnerability, and we are iterating through records of users. We could use grep extract to extract their username, for example, put this value in a dedicated column, and later copy this column, for example, to our report, if you are in a pen test or in a bug bounty. So the very first challenge we will work on is not realistic at all, but it's a good way to practice recursive grep. So let's see challenge 1 on mini-app. Okay, so here we simply have a form. We are told there's around 10 users, 10 valid users in the DB, but more than 1 billion entries if we include everything stored in the DB. So of course it will be very costly to iterate through all the settings, all the records. So we need a better strategy. The form is pre-filled with value 1. And if I submit this form, I get the following response. So the response is a JSON object composed of 2 fields. The field user is itself a JSON object describing the current user. So that's user 1, because we requested ID 1. And here we have a second field called next with a value. This value is the ID of the next user. So technically, what we have is very similar to a linked list. So if I want to access the next user, I need to pick its ID, go back to the form, submit the value, and I access its details. And once again, I get something like a pointer to the next user, so I can go through all the users that way. Okay, so we want to automate that. And if I get back to number one, this is the value I should extract in order to progress automatically through the records. So we will define a grep extract on this value, and then we will use payload type recursive grep in order to provide the value of the next field as the next payload. Okay, so let's see my proxy story. Here we go. We can see here we start with ID 1 and we get the same output than in the browser. So I will send this request, this exchange to Intruder. Here we go. A quick remark, most people believe that when you send to intruder, for example, you are sending only the request. This is not true. You are sending the whole exchange. Here we can see the request, and the response is visible too in settings, grep extract. So here, if I click on add, I will see the response forwarded from proxy history. As expected, this is a response, and here I will define which value should be extracted. So I will simply select the value of the next field, and Burp will automatically populate the start after and end at delimiters. So they are correct. I will simply remove the ending curly brackets so that if the fields are returned in a different order, I'm still extracting the next value correctly. So now I can click on OK, and this is my grep extract. Now I want to reuse the value extracted by this configuration. So I move back to payloads. I will select the payload type recursive grep. And here, that's exactly the screen I show in the slides. So we need to define which grep extract we want to use. For now, there's only one, so that should be easy. We need to define the initial payload. Given it's a recursive processing, we need to explicitly start somewhere. So I will start with ID 1. And this is easier to explain when I have the intruder results. So for now, I will simply check the box. Okay, what's left? I need to define my injection point. So I will inject here on the value of the ID parameter. Perfect. And if I run the attack this way, I will get some error message. So just try. At least on the pro version. If you're using the community version, you will probably get something different. So if I click on start attack, I get this message stating that recursive grep cannot be used with multiple threads. And if you think about it, it makes sense. It's a recursive processing. We need to have the latest value. And if we have multiple threads, it will be very hard to identify what is the latest value. So all we need to do is to move to resource pool. And I will create a new pool called single thread with one thread. Okay, now if I run the attack again, it should work. Perfect. So apparently everything is going well, and the attack should stop automatically soon. Okay, done. And now we can analyze results. So we can see that we provided payload 1. And in the response, the value of next is 1436. That's exactly the value which is extracted with our grep extract. So that will be the next payload. Accordingly, on the next line, we have 1436, and we extract another ID, etc., etc. and we iterate through all users. And at request 11, we don't have a real ID for the value of next. We have bingo plus a flag. So technically, we are done with the challenge, but intruder has no understanding of the notion of challenge or flag. So it will continue its processing. So it will use the bingo string as the next ID, and the app will return an error message, and grep extract can't extract anything. So the next payload will be an empty string. And when an empty string is used as an ID, we have, once again, the same error message. So intruder extracted the same value twice in 2 consecutive attempts, and that's enough to stop the attack if you checked the box in payload settings, this box. Okay, so we just went through a linked list using recursive grep, and now we will reuse the same payload type in order to extract not the ID of the next user, but the next CSRF token. So I can close this attack and move back to the slides. So here the ID is quite simple. For each request we submit, we will get a CSRF token in the response. So that's very, very common. Let's say, let's consider, for example, a search engine. When you enter your search criteria and you get some result, you still have the search form on top. And this form will contain a CSRF token. So every time we submit a search, we can fetch a new CSRF token from the response. So that's very easy to set up. From a network point of view, it's twice faster than using session handling rules, because for one request, we submit a value and extract a token. When we will use session handling rule, we need one request to submit the value and another request to fetch the next token. Of course, as I said, that only works if the response contains a valid token, but that's very, very common. So let's move to challenge 2. So challenge 2 looks very easy, at least in a browser. If I submit value A, so I need a value between 1 and 50. So I'm pretty sure using A will not find the value. And if I submit the form, I get some interesting feedback. The token is valid, but this is not the correct value. In a browser, that's very easy. I could simply submit values up to the correct one. But of course, we want to automate that, and we want to brute force this range in Intruder while managing tokens in an automatic way. So let's move to proxy story. We can see that every time we submit a request, we have the value we are submitting, and we have the CSRF token. And in the response, we have a new CSRF token. So here I submit a token starting with 9.3, and the response contains a token starting with 5B. And unsurprisingly, the next request will contain this token starting with 5B. Of course. Okay, so that's what we want to replicate with intruder plus recursive grep. So I send this request to intruder, and I need two injection points. First, this is the value I want to brute force. So this is something between 1 and 50. And this is the CSRF token. So I will go quickly over this point. The attack type you need is pitchfork. If you are not sure, just read the documentation. That's the only payload type working for this challenge. So now I will define the payload 1, so the value of item. That should be easy. I want to go from 1 to 50. And for the second injection point, so that's the CSRF token, I want to use recursive grep. And of course, I need to define what should be extracted. I go to settings, click on add, and here I will simply select the CSRF token, and Burp will automatically define the expected delimiters. So I'm done. I define my grep extract. Here we go. And I will also define a grep match. So I will match for two strings. I will grep match for token is valid, just to make sure everything is going fine. And I will also match on please try another value, because I hope that at some point this message will disappear because I discovered the correct value. Okay, perfect. Let's switch back to payloads. Here, I need to define the initial value for the CSRF token. I could put a valid value that I would extract from a proxy story. I will instead be much more lazy. I will use invalid value, which is like invalid token. And I will modify my range in order to start one step before. So the very first value will be used to initialize the CSRF token. Okay, I need to use a single thread resource pool because I use recursive grep, and I can run the attack. So first, we need to pay attention to our grep match entries. We can see that CSRF token is valid. The corresponding string was found in all responses, except for the very first exchange. And this is not surprising because in the very first exchange, we explicitly provide an invalid token. So the application will complain that the token isn't valid. Once the initial step is over, we have a valid CSRF token every time. So that's perfect. We managed to provide valid tokens for each attempt. So that's already pretty good, but we need to keep in mind that our original goal was to brute force the form and to find the value between 1 and 50. And I can simply look at the second grep match. Please try another value. And we will discover there's 1 and 3 here, where the message doesn't appear because that's the correct value, and we got bingo and the corresponding flag. So this strategy, intruder plus pitchfork plus recursive grep, is very easy to set up, as you saw, and it works very well. There's two limits. First, it's needed that a valid token appears in the response. That's the first limitation. And the second limitation is that it works only in intruder. If I want to run the scanner on this form, that's not possible. I will need to create a session handling rule. Okay, I'm done with this challenge, so I can close the attack and switch back to the slides. Okay. So in order to support CSRF token in Scanner or any other tool, we need session handling rules. So first, I need to explain a few terms. There's 4 major components. The cookie jar is the place where cookies are stored, and Burp Suite has its own cookie jar, exactly like in a browser. And we can see the Burp's cookie jar directly in the settings. If I go to settings and sessions, here we have the cookie jar section, and if I click here, I can see a bunch of cookies. A macro is a sequence of HTTP requests, and during this workshop, we will use sequences of length 1. So each macro contains one single request, but that's not, that's just a choice. And we could have macros containing 2, 5, 10 requests. By itself, a macro is inert. It needs to be triggered by a session handling rule. So the next term is session handling rule. This is complex and or smart part, where we define when the processing should be triggered, what should be done, including which action should be executed. And we will see that one of the possible action is execute a macro. And finally, we have the session tracer, which is a debugger explicitly designed for macros and session handling rules. So if we try to map that to the GUI, the session tracer is here, the cookie jar is there, session handling rules are defined on top, and macros are the very last section. Okay. We are done with the terminology. Let's discuss default behavior. By default, and we can see the settings here. By default, the proxy will write all the cookies seen in proxy story in the cookie jar. So that's very convenient. Every time we log in a browser, the corresponding cookies will appear in proxy story, and Burp will make a copy of them. So we nearly have the same cookies in the browser and in Burp. So that's the default setting for writing to the cookie jar. That could be surprising. We discover that by default we have a session handling rule applied to the scanner. And this rule defines that every request coming from the scanner should use cookies from the cookie jar. The consequence is that we log in a browser, we pick any request from the proxy story, run a scan on this request, and the scan will be authenticated because the scanner will reuse the last cookie set via the browser. So when we logged in the browser. That's a nice tip how to improve scan coverage. So if we open the default session handling rule and we look at the scope, we can see that this rule designed to reuse browser cookies is applied only to scanner. So if you have an extension adding new scan check to Burp, let's say ActiveScan++, for example, it appears here, and the consequence is that all the traffic from the scanner, built-in checks, will be authenticated using cookies, but all requests coming from ActiveScan++ won't be authenticated. So, of course, they will be rejected by the target, and the response will only contain the login form. So if we want our extensions to be authenticated, we simply have to check this box and close our rule. And now we can see here that both built-in scanner checks and extension provided checks will both reuse the cookie jar. Of course, these settings must not be used if your extensions are explicitly manipulating cookies. And that's the case for all extensions related to authorization testing. So when doing authorization testing, you must absolutely be in the default setup where only scanner use the cookie jar. Okay, we are done with the default behavior. Now let's create a generic handling of CSRF tokens. So we need a macro that will extract a fresh token, and we need a session handling rule executing the macro and updating the outgoing request with the new token. Of course, we need to use a single thread. If not, we have a race condition, and we will rely on the cookie jar in order to be sure that both the macro and the original request are in the same session. Okay, first I will configure the macro. So I need to select the macro request. So I move back to Burp settings and I click on Add Macro. What I see is my proxy story. So I need a request extracting a token. And for example, the entry page of the second challenge will contain a CSRF token. So that's a perfect target for my macro. So I will simply click on OK on the get request to the challenge. Perfect. I will give it a name. And I have a few other settings to configure. So if we look at the slides, first, I want to make sure the cookie hard-coded in the macro is invalid. So here, there's no cookies, no PHP SSID cookie. So I can simply remove the whole cookie line. Okay, perfect. If you already have a cookie, you can simply change the value to any string, like invalid or KO or anything. At least we don't want a valid cookie in the macro request. Then I will go to configure item, and I need to define how the macro will use the cookie jar. So should we read from the cookie jar? Should we write to the cookie jar? In fact, we want both. We want to read from the cookie jar in order to be in the same session than the original request, which will also read from the cookie jar. And we want to write to the cookie jar in the case our session cookie is renewed during the processing. So we keep both settings enabled. And here we don't need to configure anything in the custom parameter location. Okay. If we look at the Burp documentation, we will learn that in a macro response, every value stored in a HTML form will be automatically extracted by Burp. So I'm done. And I can click on test macro. And I can see there's a PHP SSID. That's the value coming from the cookie jar. Okay. Did I forget anything? No, we are good. So I can close this macro, and it appears here. And now I will create the corresponding session handling rule. So I will add a new rule. I will give it a name. And a scope. So my scope will be only repeater and intruder for now, and it will include all URLs. So that's not something you should do in real life. Okay, you should have a very narrow URL scope, but here, in order to go faster, I will simply use include all URLs, but exclusively for repeater and intruder. Now, in the rule actions, I need to execute the macro. So the action we need is run macro. And there's only one macro, so that will be easy. And here we have the, let's say, the most complex part of the rule. This first section here define if the original request should be updated with a value extracted from the macro response. And that's exactly what we want to do with the token. So I want this box to be enabled, and I will update parameter CSRF underscore token. Okay. And here, this section defines if we want to update the original request with cookies from the cookie jar. And yes, we do. So I want to update PHP sysid. Make sure you don't have a typo, any typo here, and your wall configuration is broken. Okay, perfect. I'm done. And let's see the slides. Okay, we are good. And now I will first validate everything is okay in Repeater, and then I will go through the brute force in Intruder. So I can close my settings, and I will pick a request from proxy story, send it to Repeater. So what should happen? When I click on send, Burp should execute the macro. The macro will fetch a CSRF token, and then my original request, the one which is currently on screen, will be updated for both the CSRF token itself and the PHP sysid. So I can remove these cookies. They are useless for this challenge. Here I will put invalid value. And I will do the same here. Okay. So if everything goes well, we should have these two values replaced by dynamic values. And in the response, we should see a message stating the CSRF token is correct. So from the request point of view, that looks good. And from the response point of view, that looks good too. Okay, and if I submit again, I should keep this cookie and get a new token. As you can see, it works. Okay, but the final step is to do that in Intruder. So I send this request to Intruder. And I will so define these values as invalid. This is my injection point. And now the attack type should be sniper, not pitchfork anymore. Sniper because there's a single injection point. And I will configure this payload from 1 to 50. Okay, I will use a single thread. If not, I have a race condition and my tokens won't be valid. And I will also define a grep match on the validity of the token. And on the target value. Okay. Let's run the attack. And you can see how interesting grep match is. Here we can validate that our automation is working correctly simply by looking at this column. I can sort on this column, and I'm sure that all my requests contain a valid token. So my automation works correctly, and both the macro and the rule look okay. And of course, I have to find the value to be brute forced. I can sort by the second column. And of course, oops, my bad. Of course, the correct value is 33. It's the same that we discovered when using pitchfork plus recursive grep. Okay, so we are done with a session handling rule managing CSRF token. Now we must not forget to switch back to the settings and disable the rule. Perfect. Okay. So we are done with web apps. Now we will discuss APIs. So Juice Shop. So Juice Shop is a vulnerable web app which include also API, and we have some hard-coded credentials. You can create your own account. I will simply reuse the hard-coded credentials. So I move to my target. Here we go. And I will log in. And Jim at juice-sh.op, and the password is ncc-1701. And we are logged in. Perfect. So let's look at proxy story. I probably want to remove images. That's, yeah, much easier to read. And so here we are logging in. So we are providing our credentials in the request, and we get JSON web token in the response. That will that looks like a macro. Okay, that's all we get a new JSON web token, and later we have, let's say, an access to who am I that will give us our identity. Okay, so this post to /rest/user/login, that's the login request. I will highlight it. Here we go. So logging in, that's /rest/user/login. Extracting the token from the response, you can use this regular expression. And validating the token, we will use /API/users. So let's do that. I will go send this request to repeater, and I want to access /API/users. I will remove the cookies and headers. And if I submit this request, we can see that we are not authorized to access because the authorization header is missing. I can manually add an authorization header. With the invalid value. but the token, of course, is invalid and is rejected. Okay. So to make sure that everything works, I will simply pick the value from proxy story and use it in repeater. Okay, my token is valid, but is it expired? As I said at the very beginning, on this version of JuiceShop, tokens are valid 2 minutes. So let's say I will log again. The corresponding token is valid for 2 minutes. Oops, I did something wrong apparently. Okay. Let's do it slowly. I want the latest login and I want its token, Control C, go to repeater, Control V, and okay, perfect. And this token is still valid, so we can access the API and on this endpoint get the list of all users. Okay, perfect. So the very first scenario is a static header. So that's very easy to set up. We simply pick a value from proxy story and we create a rule that will simply set this value for all requests. So let's do that. In settings, I will create a new rule, call it static HOTS. I will use it only for repeater for now, or possibly intruder. I will check both. And my action is set a specific header value. And here, we need to paste a valid token that I can extract from proxy store. So I will pick this one. It probably expired, given I'm talking too much, but we don't care. We just want to see if this kind of rule work. Okay, here we go. We are done. Now I could go to repeater, remove my authorization header, and submit. And you can see that the header was added to the request. Of course, the token itself is expired. But if your token lasts 2 hours, 4 hours, or even longer, all you need is this kind of static rule, okay? You log in the morning, you update your session handling rule, and for a few hours, you have automatic login to the API, and at some point, the token will expire, and you will have to get a new one and update your session handling rule. Okay, that's quite basic and easy to set up. Now we want a dynamic header. So we will use a macro, and the macro will extract the token. So we need some specific configuration. So I go to macro, I click on add, and I want to pick the request where we exchange credentials for a token. I give it a name. And I need to configure the item. So here, we don't mind the cookie jar. There's no cookies on APIs. And we need to configure a custom parameter location. So I will simply click on add, select the value I'm interested in, and define in which context this value will be reused. So it will be reused for the authorization header, or it could be a parameter value or a header value that's the same way. And we need to define a prefix that's bearer. Okay, perfect. So this configuration will create a kind of pseudo variable called authorization, and its value will be bearer space the extracted value. I will remove this part, it's not needed, and we are ready. Okay, perfect. So we are done with extracting the token. Okay, so that's what we did. Next step is to create the session handling rule. And we will need two actions. One action will set the authorization header with a static value. And one action will update the value of this header with the value extracted from the macro response. So I will duplicate the previous rule. I duplicate the rule in order to keep the scope. So I don't need to configure it again. And here I will remove this action. And I need one action in order to add the authorization header. So this value is invalid. And I need a second action that will execute the macro, update the authorization header, and we don't mind the cookie jar, so we can uncheck this checkbox. Okay, make sure to enable the rule. And now in repeater, I will remove the previous header, submit, and we got a token. And this token is very fresh. As we can see, it's still valid. We can see that the signature ends with W0. If I send this request again, I will get a new token, as we can see. And again, and again, and again. So we get a new token for each request. It works, but it's very noisy. Like you will double your traffic, because for each request in repeater, you will have the macro which is executed before. Perfect. Now we have the very last scenario. In order to not get a token for every request, and to take advantage from the fact that JSON Web Token has a defined expiry date, we will use an extension that will provide a cache for our token. So we will use an extension called JWT Reauth, which is not available in the BF store. And I will download version 1.0.1. Perfect. And I will load it in Burp Suite. So in Burp's extension, add okay, and we are done. Make sure your previous rule is disabled. And now we have here the extension, the extension tab, and we will configure the extension. So from proxy story, we need to send the login request. So the request where we get a token in the response, and we will use set auth request. So I go to proxy story. Set auth request. That's the first action. And we can see that this setting was modified. So this is our authorization request. We also want to define the scope of the extension. So I will take the same request and add to scope. So we need to edit the scope, like everything below /API/ will be in scope. So the first column means active, so it must be enabled. And the second one is prefix, and it should be enabled too. So that's the scope we are looking for. And we have a few extra configuration. We want to define the regular expression used to extract the token. We want to define the header name and prefix. They are correct. And we want to define the validity of the token. The token is valid 2 minutes. That's 120 seconds. We will use 100 seconds just to have a bit of margin. Okay, and when we are done, we can enable the extension by clicking on not listening. Okay, so you can see that this field was populated. So the authorization request was emitted. This regular expression was applied to the response, and this token was extracted from the response. And here we have a timer, this timer will be compared to this value. When this token is 100 seconds old, it will be renewed. I will empty my logger, and we should see the automatic renewal in something like 50 seconds. So back to repeater, I will remove my authorization header, submit the request, and surprisingly, we don't have a token here. That's just a GUI thing, okay? It depends on when the extension is executed, etc., etc. So apparently, from the repeater request, nothing happened, but the response looks correct. And in fact, if we look at logger, we can see that the repeater request include the token. And my token just expired. So we can see that the extension fetch a new one, ending with NM. And here we can see the new token ending with NM. And if I execute my request in repeater again, I get a similar outcome. I will do it twice. Okay. And if I move to logger, this is the two requests I just sent. They all use the latest authorization token, which is stored in the cache provided by the extension. So here, in like 35 seconds, we should see a new request in logger coming from extension and with a new token in the response. Okay. So I will wait a bit for it to expire. There's a few seconds left. And here we go. We see the extension fetching a new token. Perfect. We are done, and I can disable the extension. And that's all my content. So thanks for listening to this workshop. I hope a few of the tricks were interesting to you. I will be around and take questions in the chat. So feel free to ask any question you have. And thanks for listening. And I hope you will enjoy the remaining content of NahamCon.
All right. What a amazing workshop. I think this was one of the most requested bug bounty related workshop, and I've been meaning to get Agaria or Nicholas to come on the stream and also come to NahamCon. So it's an honor to have him. It's great to see this also, since he does have a course on this, and getting a preview as a freebie on a workshop at NahamCon is amazing. Okay, chat, I have one question. Are you all ready for the last workshop? And does anybody want any? Should we do a giveaway before I switch over? What do you guys think? Should we do a giveaway? I'll let you guys decide. look at my commands and see what I can do with the giveaway. Just let me know, though. I want to know who is ready to do a giveaway. Hey, so I'm gonna put this is for Twitch only, unfortunately. So if you're watching on Twitch, if you're not watching on Twitch, I apologize. I don't have a way to do this, but I'm gonna give you a few quick seconds to go over to Twitch. So if you're watching this on YouTube and you want to participate, go over on Twitch, and we are going to do a quick giveaway, and I'm gonna give away a 1 month. Let's do 3 1 month Pentester Labs. I got 3 1 month Pentester Lab subscriptions. A big thank you to them for being our sponsor also as well. So if you're ready, this is the keyword to enter. All you got to do is enter that. It doesn't matter if you do it once or twice. Only once counts. So you don't have to spam it. But if you want to spam it, go for it. The keyword is NahamSec 2023. It's the one right here on the screen. Make sure you put the exclamation point. And we're going to pick a winner here in a few seconds. I see a lot of people joining it. Give it a few more seconds. And Tiberius is going to do our next workshop. I'm just waiting for him to get online. I know he's backstage. I'm waiting to confirm he's good to go. And then we're going to bring him on to the stream and wrap up with our last presentation for today. Listen, if you do win, you got to do me a favor. You got to message me on Twitter with a screenshot of your profile to prove it's you. Okay? All right. Our first winner for the 1 month subscription for Pentester Lab is Knives9. Congrats for winning. I'm going to put you on here. Note this. All right. All right. The second winner is, you guys ready? Drum roll. I'm BDan01. You're also a subscriber. Thank you so much for subscribing to the channel. I really appreciate it. All right. You guys ready for the last one? And the last winner is Disastrous InfoSec. Congrats. All right. Send me a Twitter DM. I'll send you, I need a screenshot of that's you. Show me your profile. And that's about it. All right, Tibbs, are you ready? I don't know if you can hear me. Let me see if I can. Yep, he's unmuted. Okay.
I can hear you.
There we go. All right, man. You ready to do this?
Hello. I am. Hang on. Should I turn my camera on? Okay.
There we go. Let's do this. All right. So tell us what you have before I let you, take over our stream. What do you got going on for us today? What is the prerequisite for this?
Yeah, so it's basically I'm going to go over some Linux and Windows privilege escalation techniques. I'll share, maybe someone can share the links in chat actually, unless I can do it. I'm not sure. Basically, it's on TryHackMe. I've got 2 rooms I use. They're both free rooms, so if you haven't got an account on TryHackMe, you can always go sign up for one. But
Nice.
yeah, I'll share the links. Hopefully, I can do it in chat. I'm not actually seeing a way to do it. Maybe I haven't logged in. That might be.
If you go on Twitch, you can just go into Twitch chat and just share it on.
Yeah, that might be an easier way.
Yeah,
I'll do that as well. Cool. Yeah.
Cool. Let me put us on here so you can share your screen. I'm going to remove myself.
Okay.
Let me do it like this. So you're also on here. All you gotta do is share your screen at the bottom, present, and then you'll be taken over.
Okay.
All right, ready for me to share your screen?
Yep.
Do I have permission? All right.
You do.
There we go. I'm going to remove myself.
hopefully
Thank you again.
Yeah, no problem. I'm not sure whether I should turn my camera off or on. But anyway, yeah, we'll see how it goes. So let me share the actual links in chat. So I just have to switch over a minute. Okay, so the Linux one I've just shared, and then the Windows one, which we'll do later. Okay, hopefully that worked. All right. Let me get back so I can actually see the comments. Perfect. Okay. So, yeah, these are 2 free rooms. They're both pretty basic, and the stuff we're going to be doing today is pretty basic, but it's stuff that everyone should know. So, The other thing to mention is this is going to be like it's local privilege escalation. So if you're hoping for some Active Directory stuff, that's not going to happen, unfortunately. But hopefully we should be able to show some pretty cool things. So the thing is, once you've deployed the Linux PrivEsc room, you should be able to SSH in as the user account. Now you may have, because this is a very old box, this is like a Debian 5, I think, or Debian 6 box. You may have to add this to your SSH command. I know I have to, so just FYI on that. But let me get it back over to here and get my notes up. So we SSH on, will ask me if I want to continue. Yes, that's fine. The password is password or lowercase 321. All right, and then we should get the user at Debian. Okay, so obviously there are a few things you can do with privilege escalation on Linux. If you actually want to do the entire room, there's quite a few tasks. We're not going to be doing all of these. I'll try and get through quite a few of them in the first 45 minutes, and then we'll switch over to Windows. But what we're going to try first is some basic things with file permissions and some cool things you can do with that. So what we can do is we can do a quick ls-l and look at the etc shadow file. And if we look at the etc shadow file, so this is where all user passwords are stored in Linux. So basically they're stored as hashes in this etc shadow file, which is usually only readable by the root user, and it's also readable by the shadow group. In this case, though, we see there are some read-write permissions for everybody, which is obviously bad. What that means is we can actually just cat etc shadow, and we can see all the usernames and password hashes. There's two users, there's the root user and our user. And so between the first set of colons here and the second set of colons, which is all the way over here, you have this long thing, which is the password hash. And so this is the password hash of the root user. If we're going to copy this and clear that, oops, there we go. So if I just create a root.hash file, I'm going to paste that in. Now I've accidentally copied the last colon. You don't want to do that. So we'll save it. And then I don't know what everyone else likes to use. I'm quite a fan of name that hash. So you can install name that hash using it's nth. And then you can actually give it a file. So you can do -- file root.hash. And what that will do is it'll tell you, hey, this is what it's most likely, SHA-512 crypt. But it'll also give you the hashcat number if you want to crack it using hashcat. And it'll give you the format if you want to use John the Ripper. So we're going to use John the Ripper. I think I actually have it all pretty much stored in my history as well. So I'm going to use John, give it a word list of the standard ROCU. The format is SHA-512 crypt, and the file is root.hash. And I'll press enter. And of course, it's in my pot file, isn't it? So I need to remove my pot file. There we go. That was from the demo earlier, but anyway. So it cracked it quite quickly. The password is password123. And so what we can do, back on the SSH connection, we can just use SU if we wanted to. SU to root, password 123, and we get to be the root user. Okay, so that's a pretty simple one. At any point, you can read the etc shadow file, and it might not be due to permissions here. It might be that there's some process you can take advantage of to read the shadow file. But if you ever do get read access to the shadow file, that's one thing you can definitely do, which is extract the password hash and try and crack it. Okay. The other thing, which I think I mentioned as well, is that we also have write access over this file. So write access is even better, because let's imagine that this password hash wasn't crackable. It was some weird and random password. Well, what we can do there is we can actually write a new password. There's a few commands you can do this. I personally use mk password, and if we give it the mode of SHA-512, 612, let's just say new password. Okay, it'll generate the actual SHA-512 hash of new password. So we can now just copy this. And then whatever we want to use to edit this, let's just use Vim. I think I might actually have to color. You probably won't have to do this. I know Tmux plays havoc with this sometimes. So I'm gonna Vim the Etsy shadow file. Now you could just hit I and just keep clicking delete. I personally like to sort of separate things out. So I'm going to go over here, separate out things so the hash is all on one line, and then just delete that line, and then I can just paste the hash in there. I think that worked. That's one way to find out. We do this, and then we su to root again. We type new password. Is it going to work? Authentication failure. Okay. Apparently I didn't copy this properly. Let's just double check. Okay. I see what I did. I think I accidentally took too much off. Yeah. Okay. So let's put the password in there. And then hopefully this will work. Hooray! All right, that worked. Okay, so again, if you're able to write to Etsy Shadow, it should be a no-brainer. You don't even need to crack the password. You can just generate your own and put it in its place, which is really useful. But there is a trick which I think maybe not too many people know about, which is if there is a writable Etsy password file. In which this case this box does have. So Etsy password is where the passwords used to be stored on Unix. They're not anymore because this was always a world readable file. And so if you find it on a host and it is world readable, that's fine. That's how it's supposed to be. Right? It's because this is where you basically store all the usernames with their UIDs and their group IDs and basically things like, you know, which shell they should be using when they log in, right? And they're also their home directories. So this file is okay to be world readable. However, it should never be world writable. It should never at least be writable by our user, for example. And the reason for this is you can do various things. So you'll see that every username has a colon after it with an X. The X basically means, hey, the password for this user or the password hash for this user is in the Etsy shadow file. And that's because it's backwards compatible. That's where the password used to be. And on certain operating systems, especially the old ones, you can just put a password there and it'll work. Now, the password format is a little different. And I found that if you use OpenSSL, you do OpenSSL password and then type new password, you get this really weird, actually that might, I'm going to do it on this box actually. Because I think on Kali, yeah, Kali have this, don't have the old version of OpenSSL installed. I think you can install it, but I want to be extra safe. So all I've done is I've told OpenSSL to generate a password called new password. It uses this old format. And then again, if we go into Vim and edit the password file, we can go over here and we can take out the X, put in the password, save it, and then we can change it to root again. And we are root. Just realized I probably should have let's put new password 2. Oops. Because we already did change the password, didn't we? So we'll change it to new password 2, just to be sure. Okay. Let's delete all that. Okay, now if we sudo root, new password 2. Should get us in. It does not. What did I do now? There we go. I just typed it wrong. Okay. So new password 2 does indeed get us to root. However, if you're feeling like you don't want to be that destructive, and obviously being hackers, we shouldn't really be too destructive. What you can do, let's just change it back to an X. So if you actually copy this first line here, so I'm going to copy it. Let me go into here, actually paste it there. If we now change this, let's call it new root, keep everything else the same, and then we're going to replace this X with that password that we had before. So let's just save that, copy this. So we do this. Okay, so now I have a new root. Everything else is the same. If I copy this, and we're going to vim etsy password again. Now if I go all the way down to the end and create a new line, we'll create a new user called new root with the password of new password 2. Everything else is the same as the root users stuff. Now if we su to new root and then use new password 2, something weird happens. I become the root user again. And if I type ID, I'm actually the root user. And the reason for this is, realistically, these names here are meaningless. Okay, so if we cat etsy password again, Linux doesn't really care what these are called. All it cares about is this number here and this number here. So this is the UID and this is the GID. And roots is always 0. And so when you create a new root user that has a UID of 0 and a GID of 0, all you're basically doing is creating an alias of the root user. And that's all that is. So this name is meaningless here. You could add as many users you want to this file and give them a UID of 0, and they are effectively just the root user, which is kind of cool. If there are any questions, by the way, as we go along through this, then please let me know. I am watching chat at the corner of my eye, so hopefully we have some. Okay, so those are basically the some of the main file permissions things that we can do. What we'll do now is go on to the sudo exploits. So a lot of people know that if you run sudo with a -l, sometimes it'll ask you to enter your password. Either way, it should give you a list of the commands that you can run using sudo. And as we can see, there are quite a few commands here that we can run with no password, which basically means we don't have to type our password in. And we can run them as the user root. So a lot of the times, this isn't necessarily bad, right? There may be certain commands that sys administrators want to run as root without a password is silly, but regardless, running stuff as root is not necessarily dangerous. However, some of these commands should never really be run as root. And the reason is because of shell escape sequences. Okay, so what these are basically, if you can run these programs, these are all programs which don't necessarily generate a shell. Okay, but a lot of these you can in fact spawn a shell from within the program. And if you can spawn a shell from one of these programs whilst it's running as root, the shell itself is going to be running as root. So what we can do is we can launch a lovely site called GTFO bins, and we can take one of these commands. Let's just say vim, and if we type it in here, we can see, okay, vim's here. There's a lot of things we can just click to. So this is how you generate a shell from vim. So you can generate a reverse shell. There's a good one that's just sudo. And since we're using sudo here, we click this, it's going to take us to the right section. And basically what it'll give you is either a single command or a set of commands. Like, for example, here's a set of commands. And if we just run this, it should, assuming that we have the ability to run vim using sudo, we can basically spawn a shell. Okay, now this one's actually pretty easy. So the -c tells vim to run certain vim commands, because obviously in vim, even though it's a text editor, there's a bunch of commands you can run. In this case, all it's doing is it's getting to command mode using the colon and typing !bin/sh. Exclamation point is just a way of running programs within Vim for some reason. And so basically all it's doing is launching bin.sh. So if we do this and we paste this in here, we're root. Okay, we look at that. We have all the root creds here. So if we exit though, because we're still technically running Vim, you get this weird thing, right? Press enter or type command to continue, and we do indeed spawn Vim afterwards. Okay, so we are technically still in Vim. We just managed to spawn a shell. So there's a few things you can do with that. The mmap one is actually quite cool. So if I go back to here, if mmap is version, it's basically there was a interactive mode between versions 2.02 and 5.21, which was really nice. I don't think this one has that installed. So instead, we're going to do this one, which is kind of cool. You basically create a bash, not bash script, mmap script using Lua. And Lua has an OS execute function. So all we're going to do, we're going to make a temporary directory using this command. So again, these, when you see a block of commands like this on GTFO bins, it basically just means execute them one at a time. So we're going to echo this os.execute bin.sh into this temporary file. And then we're going to use sudo nmap, and we're going to give it the script. And hopefully, yeah, now we're root. We have a root shell. Cool, right? And there's a few. You can, if you have spare time, you can go and look up what iftop, find, nano, man, orc, etc. All of these should have escape sequences if you go on GTFO bins. There's one exception though, which is Apache. Why are my caps locked? So if I search for Apache, right, you can see we can run it as sudo. Search for Apache on GTFO bins, and there's no entry there. And to be honest, I'm not entirely sure why there isn't an entry. There definitely shouldn't be an entry for getting a shell. However, file read, there should at least be an entry for, and I'll show you why. So we can still technically get some information using Apache. Now, you may think we could be able to like maybe start Apache and run the actual web server as root and then just access root files. Unfortunately, Apache is pretty locked down for that reason. You have to recompile it basically to allow the actual web server process to run as root. It'll generally, well, Apache will do it. The original process will run as root, but then for every web server process it spawns, it's going to run as usually www data instead. And trying to get those processes to run as root doesn't really work. So the question is, what can we do with it? And this is a question you should really ask yourself. If you ever come across some binary that's running with extra privileges, for example, but isn't in GTFO bins, you should look at what the binary can actually do. So if we do man Apache 2, okay, we can go down a few settings, and we can see that if you give it -f with a config, it uses the directives in the file config on startup. Okay, so that's interesting, right? So what if we can give it some weird file as a config? Because if there are any error messages that the config file will generate, maybe that'll give us some information. And it turns out, yeah, if you use Apache 2 -f, and let's just give it etc shadow as a config file, it spits out the first line of the config file when it comes up with an invalid command. So basically, because it's running with root permissions through sudo, it was able to read etc shadow, and it tried passing etc shadow as a config file. But the first line of etc shadow is not a valid command, and so it's going to say that. It's going to tell you, hey, by the way, the first line doesn't match my syntax. But the first line is what we wanted, really. It's the root password again in the hash. And so we could literally just take this and try and basically crack the hash, which we already did. So this is why you should never give up. If you find a program using sudo that isn't listed on GTFO bins, have a look and see what that program can do. Because if it can read files, or if it tries to parse things, there may be a way of getting it to spit out some useful information. So this one's a pretty fun one. Okay. Right. So staying with sudo for a moment as well, what we'll do is we'll use some of these sudo options, right, that we have. So you'll see, usually you'll have env reset, for example, which basically just resets the environment, which is good. However, if you ever see env keep with some option here, you should pay attention to it. Okay, so LD preload. Let me actually get my cheat sheet for it. Okay, so LD preload, I get confused between these two. But LD preload is basically an environment variable that you can set, and you can set it to the path of a shared object, right? So in Linux, that's a .so file. Now, when you set this, the shared object is just going to be loaded before any of the others. And so that's a reason why this might be bad when it's actually kept in the sudo config, is because you can basically put code into a shared object, which then will spawn a shell. Okay, so we go into, if you're on the box as well, basically all the code you need is in this tools directory. So if we go into sudo here and look, there's this preload.c function file. Sorry, there's a preload.c file, and all this really does, it unsets the LD preload environment variable, and then it sets the basically the UID that the program should run as 0, and then it runs bin bash with a -p. The reason you need -p is if bash tries to run as anything other than the user that spawned bash, it'll instantly downgrade to that user, right? So in this case, if we didn't use -p, we probably wouldn't get a bash shell. Instead, what we get is a user. So we wouldn't get a root shell. We get a user shell. Okay, so there is, however, we need to compile this a little confusingly. So the command is gcc-fpic, all caps, -shared, no start files, and then -o, and we can just give it any real file name. I'm going to put it in the temp directory. We're going to call it preload.so, and then just give it the actual file name. Okay, so if you look in the temp directory, we have a preload.so file here, which is the compiled version of this. And now if we just do sudo ld_preload equals /temp/preload, and then we can literally choose any of these. Let's just use Apache though. It's easier. Oh, hang on. That's because I spelt it wrong. That would help, right? LD preload. There we go. And now we're root instantly. Okay. So because the preload shared object is like loaded and run before anything else, Apache's not even been run at this point. Okay, and all we're doing is spawning this shell. And if we exit out of it, it's basically going to complain. Right now, it's going to run Apache. Okay, so that's a fun little thing as well. There's a similar trick if we do sudo-l, and we notice that there's this LD library path. So LD library path is another environment variable, which basically tells the program, hey, this is where you should look for shared libraries first. Okay, so most of these programs are going to use shared libraries. We can actually determine which shared libraries are going to be used by running LDD. So we're going to run it on Apache again. Apache 2. And we get a nice list of the shared libraries that this is using. Now, some of these are hit and miss when it comes to this exploit. You basically just have to keep trying. The libcrypt one, though, seems to work pretty reliably. So what we're going to do, in this tools sudo directory, there is this library path.c, which contains slightly different code. So instead of the init function up here, we have a hijack function, which kind of does the exact same thing. And then we just have a static void call to hijack right here. And so if we compile this, again, with slightly different code, we're going to basically create libcrypt.so, shared fpic, fpic like that, a library path. Okay. So now we have this libcrypt.so.1. It's the exact same file name here, right? And now if we do sudo ld library path equals, and just do a dot, because we're in this directory already, right? This is where we want to search, and then do Apache 2. It's going to complain, but it's also going to give us a root shell, right? And again, this one's kind of finicky. You kind of have to experiment with it. But some of these will work and some of these won't. There are various reasons, and we don't have time to get into it now. But if you think about it, it kind of makes sense why some of them don't work. Any questions about that, by the way? I see a lot of emojis being shared with the shocked face, which is good. Okay. Let's get on to cron jobs. Right, yeah, this. If you weren't shocked by any of that, this one might shock you as well. So if we're going to cat etc cron tab. Oops. So cron jobs are basically programs or commands that are run regularly according to whatever this lovely syntax means. In this case, this means every minute. You don't really have to worry about anything else. There are various sites which will decode this for you. But effectively, every minute, this script here is going to be run as root, right, by the root user. Okay, this is the system-wide cron tab. You can technically put any username here, but the root user is going to run this script. So let's have a look at that script. And we'll see that what it does is it's a simple bash script. It changes into /home/user, which happens to be the user's home directory. And then it runs the tar command. So it's going to create a tar with gzip. And the file it's going to create is this. And then we have this wildcard. Now, all of these are going to be run because of this in here. This is going to be run using sh, which is basically a sort of smaller or lightweight version of bash. And these wildcards have a weird property when they're used in bash. The easiest way to show you might be to actually just cd in here. Let's make a directory test. Let's create three files. We're going to create 1, 2, and 3. Now, if I just do an ls, oh, I didn't even cd into it. Okay, never mind. Remove 1, 2, 3, cd into test, and then we're going to create 1, 2, 3. Okay, so if I just do an ls, we get just 1, 2, and 3 listed, right? ls on its own doesn't really do anything special. It just lists the files. If we do ls with a -l, then we get much more detailed. Okay? And finally, if I do ls with an asterisk, you get the exact same thing as before. Now, you may think that the asterisk is just basically doing, hey, okay, everything in this directory, let's run it and print exactly what a regular ls would do. But in fact, what ls asterisk does is it looks in the directory and it takes all the file names and it just puts them onto the command line. So basically what this is doing is ls123. Okay? And you may think, okay, why is that interesting? Well, asterisks, they can represent files, but if you think about it, when an asterisk is expanded like this, when a wildcard is expanded, everything is placed onto the command line like this, and then the command is run. Okay, so the other thing that you can place here, right, other than file names, are command line options. And because Linux's file system is quite forgiving, if we do something like touch // and you need the / here, and do a -L like that, now if I just type ls on its own, we have quite a few files. We have 4 files, 1, 2, 3, and -L. Okay, but if I do ls star, instead of getting this again, right, like we did when we did ls star here, we get the detailed view that we would when we ran ls-l, only the -L file isn't there. And the reason for that is when we run ls star, right, what's actually happening is it's running this. And because, again, in Linux, generally speaking, this isn't an absolute rule, but generally speaking, command line options can kind of appear anywhere they want. And most Linux binaries will know how to handle this. So if you have an ls followed by number of file names followed by a -L, it's still going to interpret that -L as a command line argument. Okay? So wildcards are weird in Linux. And whenever you have wildcards, if you find wildcards in a cron job, or if you find them as part of some kind of SUID binary, right, then they can be extremely exploitable. And so in this case, we have wildcards here, and they're being run as part of the tar command. So the question is, are there any options we can pass to the tar command that could give us some interesting results? And so if we go to tar, again with the GTFO bins, we click tar. Shell. It can be used to break out from restricted environments by spawning an interactive system shell. So it turns out that you can pass this checkpoint argument, which effectively checkpoint equals 1 means, hey, after every single file that you process, please sort of activate the checkpoint and do whatever the checkpoint action says. In this case, the checkpoint action says exec /bin/sh. Now, we can't actually do this here because obviously this is running as a cron job. So just executing bin/sh is not going to work. But instead, what we could do is we could just create a file, so a script, a bash script, and put whatever actions we want in that bash script. And so that's what we're going to do here. So let me actually just remove test. Do shell.sh, and we're going to say, hey, okay, run as bin bash. What we're going to do is we're going to copy. This is a, if anyone's watched me stream, by the way, this is a very common trick I've done. So we're going to copy bin bash into temp. We're going to call it root bash. Then we're going to chmod +s temp root bash. And all that's going to do is it's going to create basically a copy of bash in the temp directory, and we're going to set the SUID bit. And because this is all running as root, we should end up with a root-owned copy of bash with an SUID bit, which means we can run bash as root. So we're going to save that file. We need to chmod it. So we're going to give it execute permissions. Okay. And so now what we need to do is create these two files. We need to modify the second file a little bit. But again, if you can't just do touch like that, right? Because it says unrecognized option. Because obviously, you know, this is technically interpreted as a command line option. However, instead, you can just do a /. And the / basically means, hey, put it in the current directory, and then there's the file name. But because you don't start the file name with a double dash, it's not interpreted as a command line option. So if we do an ls here, you see we have a file for some reason called --checkpoint equals 1. Again, don't ask me why Linux is so forgiving about this, but it is. And now we need to change this checkpoint action. And instead of bin/sh, we're just going to execute shell.sh. All right? And so if we do this, shell.sh. Okay. And let's check. Yep. Check action. So we have to wait around 18 seconds. If we watch -n1 ls temp, hopefully once this ticks over to 1612, we should see a root bash file appear. There it is. Okay, if I exit out of that. There we go. If we cd into temp again, it's colored it for me, so it tells me, hey, by the way, this is an SUID file, which is lovely. So now if we run temp root bash, again, if I just ran this and I do ID, I'm still the user, right? And who am I? I'm still user. We exit out. We do root bash -p and do who am I? Now I'm root. So the -p is really important, okay? Because again, bash doesn't like being run as SUID. It will, in fact, just try and downgrade you back. But now we have a way of basically creating a root bash file using this cron job. We could have done other things. We could have, put anything in shell.sh. It's going to be run as root. So we could have put a reverse shell in there if we wanted to. Okay. But yeah, that's a general warning. Like if you ever, and it doesn't even have to be a cron job, right? If you ever find some kind of script which runs using an asterisk and it's being run with root permissions or whatever, right? See what you can do with that asterisk, okay? Because you can create files with some really weird names on Linux for some reason. Okay. Exit out of that. Okay. What's next on my list? Tell you what, we'll do some SUIDs and then we'll finish off with NFS before we get onto Windows because we only have an hour and a half of these. So, all right. So SUID files I've kind of explained. This was an SUID file. It's a file which basically you can execute, and if the S value is set here, that means it will execute using the permissions of the owner. And so the easiest way to find them, there are various commands you can do this with, but this one basically searches through recursively the root directory and tries to find any files where the permission, the user permission, sorry, is set to S, right? And type F just means file. So we have a few. Most of these are pretty standard. Like for example, if I was just to go onto my regular box here and do the same command, because this is a VMware box, it's got a lot more stuff. But you can see you've got mount, sudo, password, gpassword, umount. These are all basic. These are all very, very common. And honestly, there's various ways you can go about learning how common these are. The easiest way, honestly, is just to spin up a few different distros of Linux and just run this command and see what comes back. Because generally speaking, the default SUID binaries on a new installation of a Linux machine aren't going to be vulnerable. Or at least if they are vulnerable, they're not vulnerable because they're SUID, they're vulnerable because of some actual vulnerability in the program. But sudo, for example, has to be SUID. That's kind of how it works. However, there are a few files here that you would never expect to be SUID, and custom files definitely fall into that category. So you have this SUID-SO file. So if we run this file, it's calculating something. And so yeah, it calculates something and then says done. So I don't know what it's doing, but we can run some analysis on these tools. So generally speaking, can run a few programs. Strace is a good one. We run Strace on this tool. I'm actually going to filter out some of the error messages, and we're actually going to grep for certain things just to make this a little easier. But if we grep for the word open or access or no such file, then run it, So what Strace is doing is basically saying it's going to show us exactly what the file is doing on every single operation. In this case, it's trying to access a few files, right? And in this case, these files weren't able to be accessed for various reasons. So there's no such file there, no such file there, etc. Until we get down to this one. So this shows it was trying to open a libcalc.so file in the .config directory of our home. And it couldn't do so because there wasn't a file directory there. So that's interesting. It's trying to open a shared object. So the only reason generally you would be opening a shared object is if you were going to actually use the code in that shared object. And so what we can do is we can actually just create a shared object and put it there. And then hopefully we can create a shared object with some code in it that gives us some kind of shell. So if I go back into my home directory again, I'm going to tools, I think we're in SUID now. Yes, there we go, libcalc. So again, this is basically very similar to what we've been using before. I'm not going to explain it all, but there's explanations on the room page. But effectively, all this is going to do is going to spawn a shell. Okay, when we compile it. So we're going to compile it again. GCC shared fpic, and then we're going to put it in the location. Actually, forget. We need to actually create the .config directory because I don't think it's there. But if we compile it now and we put it in home user.config, and it was just libcalc. So no input files. I should probably give it an input file as well. There we go. Okay, and now if we rerun the binary without Strace, we instantly get a root shell. Okay, and that's only because obviously when it got to this line and it tried to load libcalc.so, previously there wasn't a file there to load, so it didn't do anything. Now it actually loads the shared object, runs the shared object file, well, the code, sorry, which spawns us a lovely shell running as root because it's an SUID. Okay. Right. Let's do one more of the SUID files. Oh, it's gonna run it as well because we kind of interrupted its process. Okay, so if we go back to the list of files again, there's this one, SUID env. So this is an interesting one. This is why if you ever do find weird SUID files, you should probably try and at least see if there's anything in them that looks suspicious. So in this case, what we're going to do is we're going to run strings, and strings is really useful for this. So if we run strings on this file, it's basically strings is going to find, strings of certain length of printable characters. This is the thing. It's going to filter out anything that's not printable. So in this case, we can see there a reference to an SO. There's a few functions called here. The system function is called, which should have alarm bells ringing. And indeed, if we go to the last line, this shows that the service command is being called, but specifically it's not being called using its full file path. Okay, it's just running as service. Now, basically what that means is we can create our own service file, give it executable permissions, and as long as we run this from within the, as long as we put it at the top of the path, right, then the executable is actually going to use our service file. And so if we go here, I already have service.c. Again, service.c is honestly the smallest of the files you'll ever need on this in this room. So it's basically just it's a really basic C program that just basically runs bin bash. Okay, and the compilation is the easiest as well. So we're going to compile it to service using that. Okay, and so now we have this file called service. And if we do a path equals and then we reference the current directory. And basically what we're doing here, we're prepending the current directory to the front of the path environment variable. And then if we run this binary, because we have a service executable here, right? And because the SUID env binary runs service without actually referencing its full file path, it's going to have to find service somehow. And the way it's going to find service is using the path, right? And because we put the current directory at the front of the path, this is the first place it's going to look. And so it's going to run our version of the service binary, which is just going to give us a shell. Cool. Okay. We'll close off the Linux stuff with the NTFS thing, I think. It's probably going to be a good idea. Okay, so NTFS is basically the network file system. If we cat etc exports, we can see the config. So in this case, basically what this is saying is /temp is going to be mounted. It could be mounted via NTFS, and there's various few options you can do here. So it's read, write, syncs. The no root squash is interesting. So no root squash is a very vulnerable configuration option. Because basically what it means, how NFS works is it basically takes the user ID of the connecting user and it translates it to a user on the actual host operating system if no root squash is enabled. If root squash is enabled, then practically all files are going to be, all files that are written as root are going to be written as nobody instead. But with no root squash, if you're able to, for example, create a file as root, then the operating system here is going to respect it. So how we can actually, how we can actually do this, if we go into cd temp, ignore that root bash is here for a minute, because we're going to create our own. But let me get the actual IP address. And so if we go to here and I run show mounts, so I'm on my Kali box right now. We do show mounts, we'll see, okay, you can mount /temp. So let's just make temp, and then we need to mount. So just sudo mount it actually. I think that should work. Oh, maybe it is. Okay, that seems to have worked. Yeah, we're in. So I've mounted from my my main Kali box. I have a directory called temp, and I mounted it to the temp directory running on the Linux host we're targeting. Again, just forget root bash exists. We're going to ignore it. But what we're going to do instead, using our user account here, we're just going to copy bin bash again. We're going to copy it into temp, and we're going to call it NFS bash, okay? And if I do an ls-l, you should see it in here, NFS bash. All right, so if I now do a sudo copy NFS bash to, I don't know, let's just call it NFS bash 2. Hopefully, yes, okay. So as you can see, the original NFS bash was just was owned by Tiberius, but because I used sudo when I copied it to NFS bash 2, the new version of NFS bash 2 is owned by root. And because there's no root squash on here, if I were to go back to my Debian box and do an ls-l, hopefully, yes. Because there's no root squashing, the NFS bash 2 locally here is also owned by root. Okay, you may think, okay, we've got a root owned file, so what? Well, if we now, again, using sudo over here, if we chmod this and give it a +s to NFS bash 2, oops. Okay, do ls-l. Again, it's preserved it here, so we have an SUID version of bash on this side. But hopefully, if everything has worked, we do ls-l here, we have an NFS bash 2 SUID over here, which means we can just run NFS bash 2 -p, and we should now be root again. Okay, that one is kind of confusing, but it's basically the fact that the no root squash allows us to, if we have access to any root user on any system that can connect to the NFS share, we can basically create files as root, and we can change file permissions as root. Which means, yeah, we can, as long as, and you notice the only thing really we did over this side was just copy bin bash, and we copied it into the temp directory, which obviously we can do. So if you had a suitable version of bin bash locally that worked, you could do the exact same thing from this side. It's just easier to move the local bin bash. Okay. Right. Let's start up the Windows machine. Yeah, if there are any questions in chat, let me know. Otherwise, let me just open a new window. So what we're going to do firstly is let's do MSF because this is Windows, we can't just SSH on. So I need to create a reverse shell, which we're going to do. This Windows box takes a while to boot up, but effectively it has basically the same credentials. So it's user and password 321. So what we're going to do is we're just going to RDP onto the box, and then we're going to mount this, create an SMB share here, and then run reverse.exe just to get a shell. And then from then on, we're going to pretend like we've just got a reverse shell from of exploiting Windows, right? Okay, so I'm just going to edit the thing I created earlier, make it easier. Might not be up yet. All right, we're going to give it a few. This is a Windows 10 box. Yes, all of these exploits are Windows 10. Okay, this is working good. Okay. All right. So what I'm going to do is we're going to use in-packets SMB server. We're going to create an SMB server running on my Kali box with the name Kali. And then what we should be able to do here is spawn a shell. Okay, then privesc. All right, so all of our tools that we need for the room are in here. What I'm going to do is I'm going to copy 10.13.1.1.2.4 Kali reverse.exe over to here. So this box also has antivirus disabled, just to make things a little easier. Okay, so I create a new window. And I'm going to use netcat to just catch this shell. If we just do reverse.exe. There we go. Okay. Who am I? We are the user account. Okay. We are, in fact, in the previous directory. So the first thing we're going to do is we're going to talk about services. So Windows services are basically programs that run in the background. You can create them to run on demand, or you can create them to run, for example, on startup. But they can be incredibly useful if they are misconfigured. What we're going to do is we're going to use WinPeas, which is a great script, to try and see if there are any vulnerabilities on this box regarding services. And so usually you wouldn't just run WinPeas like this. You wouldn't give it specific options like services info. But just to make things a little easier, we are going to just check the services stuff. It's going to be a lot faster, for example. Usually you just run WinPeas completely and scroll through and see what you have. But if we go down here, okay, we can see there's a bunch of red stuff. Specifically, we'll start here. So it looks like you can modify some services, right? It says we can modify the DACL SVC, okay? So what we can do, we can actually verify that. So again, in this privesc directory, which you'll have if you join the room, there's this access check or access check exe. And what access check is, this is a very old version, which still allows you to basically accept the EULA via the command line. If you don't do that, you have to have RDP access to the box. It's kind of annoying. But basically, it's a really useful tool that allows us to check the access permissions of certain things. And so we do this. We say accept EULA. Let's just do the help menu. Okay. So it's quite daunting, but effectively what you can do is you can give it various options, followed by a username, followed by either a file directory, registry key, process, service, or object. And it'll tell you what permissions that user has over whatever you give it. So we're going to use a few command line options. We're going to use -C because we're talking about Windows service. All right. We're going to suppress errors using -U. We're going to tell it to be verbose. We only care about things we can write to, so we're going to use -W. And then we're also just going to use -Q to omit the banner. So we're just going to copy this again so I don't have to type it all out. So we do -UWCQE. DACL SVC was the one. Actually, we want the username. So our username is just user. So we run that. Okay, so this doesn't confirm that we have write access. So it means we can query the status, we can query the config, but more importantly, we can change the config. And perhaps more importantly than that, we can actually start and stop the servers. Because if you think about it, if we have to change config option, but we can't start or stop the service, that's going to be really bad, because it means, we could change anything about the service, but we'd have to wait for somebody else to either stop or start it. So it's important that if you do find one of these services with a change config permission, you make sure that you can either start it or stop it, or you have some way of coordinating that. Okay, so the ability to change the config let's actually see what the config is. So we're going to use the sc command with query and DACL SVC. Okay. So this tells us that the what did I do? Sorry. SCQC is what we wanted. DACL SVC. There we go. So the query is basically the state, so it's basically telling us it's stopped. The QC is basically going to tell us the actual the service config, right? So in this case, we can see that it's demand start, which means we can start it on demand. The binary path name is this thing, and it starts as local system, which is great because that's what we want to get to. So we can change anything about this, and the most obvious thing we can change, obviously, is this thing, right? If we change the binary path name back to our reverse.exe file, then when this starts up, it should spawn us a reverse shell running as local system. Okay, so what we're going to do is we're going to use scconfig, DACL SVC, bin path. Now the syntax is a bit odd. As far as I'm aware, you have to have bin path equals then a space for some reason, and we have to backslash quote everything. So we were going to do cprivesc reverse.exe backslash quote and then end the quote. Do that. We can also then double check, so we can run scqc DACL SVC again, and I actually typed it wrong, so that might not work. So just to make sure, I'm going to run that again. I'm sure it's probably okay, but who knows? It's Windows. Okay, so let's just run this again. Okay, much better. And if I do a dir, we should still have the reverse.exe here. Good, okay. So I'm going to create a new window. I'm going to use netcat to listen on port 4444 again. And then to start this service, because it was stopped already, if we go back up, stopped here, we can just use net start DACL SVC. Okay, it's going to start it. This window is going to have us a lovely reverse shell. If I do who am I, we can see empty authority system. Perfect. Okay, so let's go back up and have another look at some of these vulnerabilities that WinPeace found. WinPeace found this one. An unquoted path service, no quotes and spaces detected. So this is an interesting one, honestly, because it's kind of very strange how Windows works in terms of finding an executable. So actually, I'm going to copy this. Actually, no, I'm going to do this first. We're going to actually have a look at the service this side. So if we do scqc unquoted SVC, okay. So if we compare this to what this one was before, you see this binary path name here. It was in quotes. The binary was in C program files, DACL service, DACL service.exe. And you'll note there are spaces here. All right. And similarly, in this one, there are also spaces. Okay, there's quite a few of them. But there aren't quotes around it. And this is the difference between these two things here. So if I was to copy this one, actually, and let's copy the original. Okay, so on Windows, if a service has quotes around the binary path, quotes basically tell Windows, hey, this is exactly where you need to go. Okay, so this is the entire name of the executable. This is the exact path to the executable. Okay, and this is important because things can get kind of weird when you don't use quotes. And the reason is kind of like on Linux, where you have the path environment variable, which tells you, or tells Bash or whatever system you're using, where to find certain executables. Windows has the same thing. Windows is also very special in that even though most of its executables have a .exe, you can, generally speaking, run them without the .exe, right? So to give like an example of that, if we were just to run calc, right? I haven't done calc.exe, even though the binary is calc.exe, yet it spawns a calculator. Okay, and so we can kind of abuse these two because the file path name isn't actually, the bin path, the binary path name here, is kind of misleading because it's not a path to the binary. It's a path to the binary plus any command line options you want to pass to it. Because obviously you could pass command line options, just as you could do like an ls-l, right? The binary is ls, the -l is the command line option. You can do the same thing here. And so the problem comes when you have to differentiate between what is a binary and what is an argument, right? So if we have quotes around this and we want to give the option, I don't know, --config test.txt, okay, Windows understands this. Windows knows that, okay, everything's surrounded by quotes. That is the path to the executable. So I'm going to execute this, and then I'm going to pass it two command line arguments. One is --config, one is test.txt. The same is not true over here. If we would do the same thing here, because everything is separated by spaces, Windows looks at this and it gets confused because there's a space here, there's a space here, there's a space here, there's one there, there's one there, and there's one there. So Windows is sat there thinking, what's the executable here and what's an argument? And obviously we can tell that this is clearly the executable, right? It ends in .exe, but Windows doesn't know that. And Windows also knows that it doesn't need a .exe, right? To run a command. So basically when Windows parses this string, and we don't even need this anymore, the first place it's going to look for an executable is it's going to see if there exists a program.exe, right? And if program.exe exists, it's going to run that, and it's going to pass it this as an option, this is an option, this is an option, and this is an option, okay? But obviously program.exe does not exist. So the next thing it does, it goes to the next space. And so it's going to go up to here, and it's going to look for unquoted.exe in the program files directory, okay? And if it finds unquoted.exe, it's going to pass it path as an argument, service/common as an argument, and files unquoted path service as an argument. Okay, and it continues. So we can go to here. It's going to try and find unquoted path.exe, and it's going to do this instead. It's going to do this one. So common.exe with one option, files unquoted path service, and then finally it's going to run the entire thing. So when this unquoted path service runs, it's actually going to check for basically 5 different executables. It's going to see if program.exe works, unquoted.exe, unquoted path.exe, common.exe, and then finally it's going to find one that works. But the fact is it's going to run these in order. It's going to check for them in order. And so if you have a binary path name in a service which is unquoted and it has spaces in it, then this is potentially vulnerable. Because if we can write to the C directory, for example, or the program files directory, or the unquoted path service directory, we can create one of these files, right? So we could potentially create unquoted.exe. So let's actually have a look and see if we can create anything. So we're going to use access check again. The access check exe except UWDQ. Let's just check the C. So the C drive, we we have read write, but we don't actually. So the thing is, I think we can write folders. We can't write binaries to it. So we can't do that. But if we run this again, and we need to quote this now. If we do C program files, oops. Well, I think that actually worked. So again, we don't have write access to this. And if we try, what was the next bit? Unquoted path service. Unquoted path service. Okay, and now we do have, in fact, read write. So we have write access to this unquoted path service. All right, and so if we go back and look at one of the possible outputs, we see, okay, well, we can't create program.exe, and we don't have write access in the program files directory, so we can't create unquoted.exe or unquoted path.exe. But we do have write access to the unquoted path service directory, which means we should be able to create common.exe. Okay, and so now if we just copy the reverse.exe into C program files unquoted path service, and then call it common.exe. That copies, and we can actually confirm that. Should we quote this? In fact, I'll just do. Okay, so we have common.exe there. I'm going to disconnect that. And now, if we do the standard command net unquoted svc, which is the name of the service, we get a shellback. Okay, and that's because when the service starts, it goes through all these locations. It doesn't find a binary at any of them until it reaches this one, and it executes common.exe. Now, when it executed common.exe, it passed this string files / unquoted path service.exe to the binary itself as an argument. But because our reverse shell doesn't really care, realistically, you can pass arguments to any kind of binary. It'll only care if it actually checks the arguments. So yeah, the person in chat asking about the arguments, no, it doesn't care about any of them. If you were to check arguments, then yeah. But the thing is, since you're in control of the program itself, you could just create a program which doesn't check the arguments, right? The arguments are just going to disappear into the ether. They're going to be technically passed, but because there's no check, it doesn't matter about them. Okay. I'm just trying to see how much time we have. We probably have like 20 minutes. I think we started about 10 minutes later than usual. Okay. Let's try a few more things then. We're going to try always install elevated, I think, which is a fun one. So if I do the again, we're going to run WinPs. I'll do Windows creds. Again, generally speaking, you wouldn't just pass Windows creds to it like this. You would run the entire thing and look back. Thanks, Namsec. Yeah, I think we're good. I think I'm on time. So I'm just passing it these arguments because I know exactly how to find the right thing, and it's just going to run it very quickly. But in this case, this checking always install elevated. Always install elevated is set to 1 in HKLM and HKCU. So basically, you always, if you're going to find this check, if always install elevated is set to 1 in only one of these two registry entries, then you cannot execute this exploit. However, it's set to 1 in both, then you can, which is great. Always install elevated is basically, it's a way, I don't know why it's quite in Windows, but effectively if you have a Windows installer, an MSI file, and you run it, then if these are always set to 1, then it will install it using local system, even if you aren't technically running it as local system, which is kind of weird. But what we're going to do here, we are going to use MSF Venom again. And I think we're going to keep most of this the same, actually. We're just going to change this to reverse.msi and this exe to MSI. All right, so MSI is the Microsoft installer file. Okay, so we have reverse.msi. I should still have my connection there. Good. Okay, so if I do NC again, listening on 4444, and if we go back here, we can use MSI, MSI exec, quiet, QN, I. So I did this a few weeks ago on stream and it didn't work for some reason, so we're going to have to hope that it does work, but I didn't copy it actually, so it wouldn't work anyway. Let's copy it first. 10.13.1.124 Kali reverse.msi. Okay. So hopefully, do dir. Reverse.msi is there. Excellent. Okay, so now we should be able to do MSI exec /quiet /qn /i c reverse.msi. And hopefully, there we go. Okay, it worked, thankfully. All right, and who am I? Now authority system. All right. So yeah, basically, it's a weird quirk in Windows. Again, it's extremely rare, but there are CTF boxes where this has been the privilege escalation, and effectively, it's just the way that MSI works. So the way that Microsoft installers work. What's the part we're abusing? We install MSI files, local system. It's just part of the MSI installer process, really. So the way the MSI exec works, if you have these specific registry keys set, for whatever reason, I don't really know why it was ever put there, but if they're enabled, it will run everything using local system, which is lovely. Okay, so we can kill that. Okay, moving on. The next thing we'll do saved credentials, or credentials in general, to be honest. So again, we're going to run WinPs. Do CMD and Windows creds. Okay, we scroll back up. Checking credential manager. So another weird quirk of Windows is you can technically store credentials, which is kind of weird. But basically, yeah, you can store credentials in the credential store, and then you can reuse them without actually knowing them. So in this case, if we look down at the credential manager, we can see, okay, we have these generic credentials, don't really care about that. But we have this user, the admin user. We don't know their credentials, but the credentials are stored in the credential manager. Really, all that means is that we can reference them in several commands. The easiest way to use them, if we actually do command key list, it should also list them here. The easiest way to use them is within the run as command. We do run as. Okay, I guess that doesn't work. I would have thought run as would have a help menu, but apparently it doesn't. Anyway, with run as, ordinarily what you would do is you would do like a user admin, and then you would tell it what to execute, and it would ask for the password, right? that's how run as generally works. You have to know it's almost a bit like sudo. You have to know the password to run it. But in this case, if we do save cred, because we're running it as the admin user and the admin user has a saved credential, right, we can actually just use save cred and skip all of that. So if we do c privesc reverse.exe. Okay, and it's used, the credentials didn't prompt me for anything. And if we do who am I here, we're actually the admin user right now. Okay, so again, not too common, but if you ever see it pop up here when you're looking through your WinP's output and you see that there are credentials stored, it's always worth trying it. And it even tells you, here you go, use run as with save cred. The key thing is you do need to specify the user. So here I specified user as admin. Okay, but that's a pretty simple one. Other one we're going to do is we're going to do some hash extraction. So cancel this. If we have a look about on the file system, the SAM and system files are incredibly important. They're basically where password hashes are stored. And so if we can ever find, those files are generally locked while the system is running, which is a good thing. However, there are occasionally chances where you could find them as backups. And again, I know a few CTF boxes which have used that as the way in. So if you can ever find a backup of the SAM and system file, you can extract them and then basically extract the password hashes locally. So if we go into C Windows repair, and again, I think WinPs will find this eventually. If we do a dir, in the repair directory, we do indeed see there is a SAM and system file. This is not the usual location of them. The usual location is in Windows System 32 config. So we have them here though, and we can copy them back to our Kali box. So we're going to do 13.1.124 Kali. So we're going to copy SAM, and system file will take a little bit longer. Copy system back to 10.13.1.124 Kali. Okay. Still copying. This might take a little while. I think it's actually done. It looks like it's actually done. All right, well, if it's done, what we can do, we can use this tool. So this is actually my own fork. So this is a Python 3 fork of cred dump because the old version didn't work anymore. So yeah, if you go to my GitHub, it's basically there. It doesn't work on like 3.10 Python. It works on 3.8 at least, which I think I have installed here. Yeah. So if I do password dump, and then we basically need to pass the system file and then the SAM file. And so in this case, we go to Windows System, Windows SAM. Interesting. Am I not in the right? Oops. This was working earlier, so I'm not entirely sure. Maybe it's this thing's. It shouldn't have to use Python 3, but we can try it. Because I have a weird, so I'm using pyenv. Okay, I'll tell you what I'm going to do. I'm going to copy. I'm going to copy the system and SAM to here. And then we're just going to use there we go. I don't know quite why that doesn't work, but whatever. So if you copy it locally, apparently it's fine. But yeah, so basically if you use password dump combined with the system and SAM, you have to do this because they're encrypted, and I think the system file has the encryption key or something. But anyway, you need both to decrypt the actual hashes. And so now what we do is we have the admin hash here. If we copy this entire hash, this is 2 hashes technically. There's the NTLM portion here and there's the LM portion here. We need both to do a pass the hash, at least in terms of the tool we're going to use. Sometimes you only need one, but the tool we're going to use is pass the hash win.exe, like this, right? So pass the hash win.exe. We're going to give it the admin user. And then we're going to say percentage the password hash, and then we're going to do the location of the server, which is going to be this one, and then whatever we're going to spawn. So we're going to run cmd.exe, and hopefully there we go. Okay. So we basically just use pass the hash to log on as the admin user to the system and spawn the cmd.exe. Now, because we are an admin user, because technically this is not just called admin, because we are an admin user, we could very easily upgrade to the system user if we wanted to. There are various ways of doing that. If you've ever used get system as part of Metasploit, then you'll know how. But we can do it using pass the hash win.exe by just doing the -- system argument there. And now if I do a who am I, we should be NT authority system. Okay. All right. The last thing I was going to show was we kind of have to basically one of the print spoofer kind of exploits. So print spoofer is quite old now, but it's still kind of reliable. This is if you get a service account on or on a Windows server of some kind. And so what we're going to do, we're going to kind of cheat here for a little bit, but we're going to simulate getting a service account as a service account shell, I should say. So what we're going to do, we're going to set up another listener here. I'm going to go back onto Windows here. Actually, you know what I might be able to do is just run it, because I already have this. I'm already running it as system here. So I think what I should be able to do here is go to cprivesc. And if we do /psexec 64.exe. So again, the only reason I'm doing this is to simulate us actually getting a shell as a service account. All right. So basically, I'm saying, hey, we're going to run the reverse.exe as NT authority local service. Okay. So if I do this, cprivesc reverse.exe, that should work. Okay. So we get a shell here, and if I do who am I, we're not local system, we're local service. Okay, we are a service account, and that's the end of the simulation. We now have a reverse shell as a service account. You might get this, for example, if you have somehow exploited a web server or a database, okay, because they generally speaking run as service accounts. So we have a shell running as a service account. What we're now going to do is we're going to set up another listener. So we're going to set up another listener here. And we're going to go back into our privesc directory. Now what we're going to do is who am I /priv. Because we're a service account, we have this lovely SE impersonate privilege enabled. And effectively what this enables us to do is to impersonate other users. However, there are serious limitations behind it. Apart from when you're using exploits like the potato series of exploits, you have like juicy potato, rotten potato, what's the most recent one? I forget the most recent one, but anyway, a lot of potato exploits take advantage of this privilege, and so does print spoofer. And print spoofer, I believe, hasn't really been fixed on most of the operating systems that it was vulnerable to. But yeah, so if we actually just run God Potato, probably there's Rogue Potato here, but we're going to use print spoofer, which is just the easiest to do, and that's what we're going to end on. So we run print spoofer here, and we're going to give it -i-c, and then we're just going to tell it, hey, can you run the reverse.exe again? And hopefully, okay, because we're using the SE impersonate privilege, it found it. It created a name pipe, and we're system. Hooray! All right, that was the demo. We ended pretty much an hour and a half later, which was good. But I would definitely recommend, if you got confused, I realized we kind of blasted through this quite quickly. I just wanted to show a bunch of cool things. There are a lot of other content that we skipped over, and these rooms are free on Try Hack Me, so you don't need a subscription. You just really need to sign up for an account, and you'll instantly have access to these. But yeah, both of the rooms have way more than what I showed, especially different ways of abusing shell features, for example. So I would definitely recommend going through these. Yeah, I hope everybody enjoyed the workshop. Hopefully some people were able to follow along and hack some stuff with me. But yeah, I hope everybody enjoys the rest of NahamCon as well.
Where's on mute? Hey, thanks for doing this again, man. I really appreciate it. I know people enjoyed it, and the chat was pretty engaging for you. So thank you again for doing this. For people that are not familiar with what you do, I know you stream on Twitch and you're on Twitter. Where can they find you? Where can they, watch more of your stuff?
Yeah, Twitch is probably easiest. So it's twitch.tv/0xtiberius, unfortunately. The same on Twitter. Yeah, I'll post it in chat, I guess. Yeah, I stream usually every Monday, Wednesday, and Friday, with exceptions. Yeah.
Sounds good, man. Thank you so much. I put the link right here. So if you're watching this and you want to go watch more of tips, go ahead and just go on this link right here. Thank you so much, man. I really appreciate it. I'm going to wrap this up. I'm going to let you go, and I will talk soon.
Awesome. Thanks, man.
Cool. All right. That was all of the workshops for today. What did you guys think about doing the 2 days? Was this something you enjoyed? 2 days is the right move for next year, or should we go back to doing one full day? What do you guys think? Do you want more of this? 2 days? I think 2 days is the go-to for next year, but we'll see. This was a hard week to do 2 events, but we pulled it off, chat. All right. I know the other thing is it's late for some places right now. So in Europe, it's like 10 or 11, and most people don't want to stay up past this time. So hopefully this helps. Same thing tomorrow. We'll be back online tomorrow at 9 a.m. my time. Same time we started today with all of the talks, and then IPSEC and Al are also going to be there. All right. Enjoy your night. If you're in the US, it's still kind of afternoon for you, or evening. Enjoy your evening. Everybody else, come hang out with us on Discord. I'll be around. Everybody else, see you tomorrow. Peace.